Warm welcome, friends. So we'll continue our discussion on lines, angle, triangles. In the last lecture, we talked about the angles. So primarily, we talked about the corresponding angles, the alternate angles. Of course, the questions built on that, the applications built on that, which appeared in some of the entrance exam. All right. Then we talked about the vertically opposite angle. We spoke about we spoke about the supplementary angle, the complementary angles, right? These names, the importance of these names and the application built around these names. That's what we saw in the beginning of the lecture. Then we went on to some of the basic properties of triangles, especially we spoke about the sides. So where we said that so we said that how the perimeter, given the perimeter and the sides are integers, how can we find number of different triangles? Or given some two sides and the third side is asked, so using where two sides are integers, the third side is also an integer, right? So then the number of values the third side can take, integral values the third side can take, such that some acute angle triangles are formed, the obtuse angle triangles are formed. All right, we looked at those properties, the conditions governing such constraints. Then we spoke about then we discussed about the right angle triangles. More so into the right angle triangles, we spoke about three theorems and some of its applications, right? We spoke about 5 important Pythagorean triplets, and we also talked about 45 45 90 triangle. That's a theorem of 45 45 90. Then we spoke about theorem of 30 60 90, and we have seen here and there some applications built around that. And we also spoke in that particular lecture about the centers of triangle. We said that there are primarily 4 centers, although we know that there are 5. We spoke about 4 centers, which are more fashionable in the exam. We talked about the centroid, that is the point of intersection of medians. Then we talked about in center, which is the point of intersection of angle bisectors. Then we spoke about the circumcenter, which is nothing but the point of intersection of perpendicular bisector of sides. Then we talked about then we spoke about the point of intersection of altitudes, which is nothing but the orthocenter. Now these are the different things we spoke about in that particular class, and also of course we looked at some of the applications built around that, right? So that was primarily consumed first 2 hours of our core geometry lecture. So what we'll do today is we'll talk about the further aspects of it. Maybe what I'll do is I'll spend the similarity of triangles, which is one of the very, very important concepts. Simple, alright? No, similarity is no big deal about it. The similarity is nothing but two things look alike in shape. The size can be different, right? The shape can be same, the size can be different. But what for us more important is what? So what are the applications on that? Okay, so I understand similarity. I may understand theorems, already the rules governing similarity. But the point is I should be able to notice that, and then I should be able to work upon those particular questions, right, which becomes important to us. That's what we look at the first half an hour of our discussion. Then we will speak about the various theorems in various theorems in triangles, right? Nothing but the angle bisector theorem, the basic proportionality theorem, right? These are some of the Apollonius theorem. We'll speak about some of the theorems basically governing the triangles. Then we will unleash into various kind of problem solving built on that, right? So technically it's a 2-point agenda. One, the theorem. Now, so we talk about the theorems in triangles. That's one. The second one is the similarity of triangles. This is the 2 major heads, and then of course we'll do quite a few questions covering what we did in the first lecture and also this particular lecture. If anybody has not gone through the first lecture, that of lines, angles and triangles, I strongly recommend that you please do so. Either now or before, either now or later, whichever way suits you. But please go through that, because I will be connecting some of the concepts that we covered in that lecture with this lecture. I'm not saying that there is a large intersection between the two, but I'm saying there would be some commonalities between those 2 lectures. Those common points probably I may not be explicitly mentioning in this particular lecture, right? Good, great. Let's get going on this note. So here we go with the first point agenda that we are talking about, similarity. Now, more often what happens is, okay, so it's fine to say that, okay, the similarity, it's not that, okay, none of us understand. We all clearly understand what we meant by similarity, right? So but the point is, practically, how do you find out this similarity is what actually challenges most of the people. When it comes to the exam, the practical aspects is what troubles the people, not the theoretical aspects of similarity. Everybody will be able to find out the theoretical aspects of similarity. What troubles often is the practical aspects aspects of similarity. Keep these triggers in your mind. So I want you to keep tolerant triggers in my mind, in your mind. Maybe one at a time can be used, more than one at a time can be used. Technically, in my experience, I understood that more often than not, when we talk about the similarity, one of these, more often than not, I'm not saying that these are the only three triggers. Okay, there are the very complex diagrams with similarity, but that complex is very rare. I don't have to bother too much about such complexity. But then 90 or 9 out of 10 questions can be observed. Some of these three parameters can be observed in 9 out of 10 or 10 questions. First, let's pay attention to that. First, okay, even before we pay attention to that, first let's quickly understand the difference between the similarity and congruency. I'm sure you guys might have heard about these words, right? So you would have heard about this particular word. What I'm talking about similarity and congruency, isn't it? Yeah, one is similarity and congruency. Okay, so what is that? Now, what is this matter of this? One of them is to do with the shape, the other one is to do with the size, right? Shape, the other one is to do with the size. If you simply put it, if I simply put it, I just have to help you to understand what is this. Similarity is shape is same, size is not same, right? That is like your mobile. Take your mobile, you have a picture, so you want to so zoom in, zoom out, you want to make that picture large, or you want to make it small. So what does not change? The shape of that picture does not change, the angles won't change. Basically, shape won't change means the angles won't change, the curves won't change. What could change? The size may change. The size of the picture keeps changing. That is what your zooming factors are. You are zooming in, zooming out. That's what happens there. Size keeps changing. What does not change is the shape. Shape does not change. The curves remain curves. So the angle remains angle. That does not change. Therefore, really, you may say from our perspective, shape remains same means what? The angles remain same. Shape remains same means angles remain same. Therefore, the angle is my reference point. Whereas for the congruency, what I meant by congruency is the shape is same and the size is also same. That's the congruency, right? That both shape and size are same becomes the congruency of the triangle. That's simple, right? Simply put, that is what it is. Therefore, in similarity, what is the key thing, my friends? What is the key thing? Key thing is the angles. Key thing is the angles, as I put there. So because what does not change? The contours, the angles, the curves, all of that does not change. What change is the size of that particular thing keeps changing. Therefore, just remember that. Therefore, the focus when we talk about the similarities, that's what you would have learned from your primary school or high school. Your teachers would have clearly told you similarity means shift your attention to angles. Just like when I say that median, or just like centroid. Centroid means what? Shift your attention to median. All right, when we talk about in center means shift your attention to, because go to the root cause. All right, how do you arrive at that? The moment we say that, okay, the moment we say it's a in center, shift your attention to what? Angle bisectors. Similarly, the moment we talk about the similarity, shift your attention to what? The angles. If two angles of a triangle are equal to two other angles of the triangle, the third angle would automatically match. Your task is to just figure out that, man, I'm getting two angles equal here. The third angle would automatically match. That is the core. That is the core of similarity. What is core of similarity? The angles is the core of similarity. Right now, it is not the size, because size keeps varying. Therefore, it is not about the length. It's about the angles. Okay, let's keep that in mind. Now let's come back to this. Let's come to this particular diagram. Assume that on your mobile you had this particular diagram ABC. Assume that on your mobile you had this particular diagram ABC. What did you do? You do into 2x. You did into 2x, the outside diagram, into 2x. Hey, what do you mean by into 2x? You are trying to say that, look, man, all right, now. So AC divided by DF. All right, AC divided by DF is nothing but 1 by 2. All right, AC divided by DF is 1 by 2, which means if the length of AC is 1x units, all right, 1A unit, all right, if this is 1A unit, this is going to be 2A units. This is going to be 2A units. What did you do? You multiplied scaling factor. You used a zoom factor of into 2 times. Great. All right. Yeah. What if the length of BC? All right. Length of BC is 1B unit. All right. 1 full unit. B. Length of 1B unit means what? B. Basically, I'm trying to say that, hey, let us assume that this particular size is A. Let's assume something like that. This particular length is A units, this is A units, this is B units, and this is C units. Now what I'm trying to say is, look, the outside one in that particular case, the outside one, this is going to be 2A units, and this is going to be 2b units, and this is going to be 2c units. Hey, why you are saying 2a, 2b, 2c units? Because you made the multiplication factor as into 2. Hey, what if I had made it as into 1.5? Then you write 1.5 for the outside diagram. Just into 2 is just an example for you. So therefore, what you can say about it, so what is that similarity you are talking about? See, what does not change? Remember clearly, my friends, if this angle is x, this angle will remain x. That does not change. It is not that, hey, this becomes 2x. No, man. Well, if that is x, this is also going to be x. The length can vary. A went on to become 2a. That's right. But what does not change? The angle opposite that length did not change. If it is x, and it is x. All right. So how do you write? Now you write something like this. Now take a little triangle. Let's take an angle x here. X becomes the reference point. I told you very clearly, isn't it? I said that, hey, man, angle is the reference point. Angle is the reference point. Side is not the reference point. You will always write the phrase associated is side opposite angle. Remember this phrase, side opposite an angle. All right, side opposite an angle. That is the phrase that you use there, isn't it? Side opposite an angle. Your teachers in the high school might have used this phrase so often and so many times while talking about the similarity of triangles. Side opposite an angle. Right, that's how they would have said, because the angle is the reference. This is x degrees, let's say x degrees. Now look at this, friends. Take two triangles now where we know that two triangles are similar. Which are those? Triangle ABC is similar to triangle DEF. Triangle ABC is similar to triangle DEF. Now look at this. Side opposite. Use this phrase. This is the phrase I want you to remember. Side opposite angle X in triangle ABC. What is it? Well, that's nothing but BC. That's nothing but BC. Now side opposite friends, opposite. Look the side opposite this angle. Similarly, look the side opposite this angle in the larger triangle DEF. Side opposite this particular larger triangle DEF. Side opposite which angle? Angle X. What is that? That is nothing but EF. That is nothing but EF. Hey, do I know this ratio, by the way? Yes, you know this particular ratio. Hey, what is this ratio, my friends? This ratio is nothing but 1/2. This ratio is nothing but 1/2. Hey, why did you take 1/2? That's the assumption I made. I made an assumption into 2x. Zooming factor. You made it. Now zoom in. You zoomed it by 2 times. Zoom times. Therefore 1/2. In this case, it's 1/2. That's a ratio there. Okay, let's keep that 1/2 in mind. Let me go to the next one now. Let me call this angle as y. Then I'm sure that this also is going to be y, because the contours are not going to change, isn't it? Now this y becomes my reference point. That's a point I'm trying to make. Hey, this y is my reference point. Now what I should do with this y? The side opposite this angle. What is the side opposite this particular angle? B. No, that's nothing but AC. Side opposite this particular angle is nothing but AC divided by side opposite in the other triangle. Side opposite this particular angle. What is that here? That is nothing but DF. That's nothing but DF. Good. So now what is the ratio of this? Ratio of this is also 1/2. Whatever is that, because this was B here, then this has become 2B, because that's also 1/2. Good. That's what you are trying to say. Therefore, can I equate them? This is equal. Of course, yes. You can equate it and you can call it as equal. You can call it as equal. Similarly, you can say that my third angle is going to be Z. Therefore this also becomes Z. By whatever the explanation I gave for the other two, the side opposite these angles, you can write this. Therefore Z as the reference point, write the side opposite of this, which would become AB divided by DE. AB divided by D. They are all equal to, in this diagram, what? 1/2. In this diagram it is 1/2 because I made an assumption that the outside one is having a zoom in factor of 2 times, right? 2 times. All right, now that's what we did there, into 2 times. So therefore it is 1/2. Otherwise, okay, now theoretically what is that I'm trying to say, right? If it is a similar triangle, ratio of sides would be equal. The ratio of sides would be equal. That is, BC divided by EF would be equal to AC divided by DF, which also would be equal to AB divided by DE. Now what is the reference point? The reference point has to be angles. Take an angle as the reference point and then write the sides opposite those particular that angle. That ratio of the corresponding sides. We use the word the ratio of the corresponding side. How on earth you are going to understand that they are the corresponding sides? You take angle as the reference, because in similar triangle, what does not change? The angle does not change. does not change. Okay, just keep this in mind. All right, just keep this in mind. Now this is what you mean by the similarity of triangle, which you study kind of in the class 7 or so, class 7 or class 8. That is when you will have the first tryst with this similarity of the triangle. Let us keep this in mind. Let's keep this in mind. Also, in this similarity of triangle, there is a second way to remember this. There is a second way to remember this. I want you to remember this one. The second way to remember, I will write it here itself so that all the things will be clear. Second way is, if two triangles are said to be similar, then the ratio of these sides, this from the high school you would have learned. All right, now this will also be same as this ratio. The size can be different, but the ratios will be same. Now look at this ratio, friends. Look at this ratio. All right, now what is that you called? A is to B is to C. That's what you are saying. A is to B is to C. Now look at the corresponding ones here. You are saying that this is 2A is to 2B is to 2C, 2A is to 2B is to 2C. Hey, what happened to that 2 now? The 2 got cancelled. Therefore, now the first ratio is what? A is to B is to C. Hey, what is the ratio here? Here also it is A is to B is to C. There was a 2, of course, attached to this. But what happened to that particular 2? 2 got cancelled. Therefore, what remains constant? The ratio remains constant. That is also fine. So therefore, people remember now what I wrote here. This is, people remember this as the horizontal perspective. This, remember it as a horizontal perspective. That is A is to B is to C. That's a horizontal perspective. Therefore, the horizontal perspective, what I briefed before, is called as the vertical perspective. I don't know what your school teachers would have said. Something like that your school teachers would have said. What was the vertical perspective? This was the vertical perspective. Vertically, they will be equal. This is the vertical perspective. Either on it. Now, so which one to use in the question depends on the data. Sometimes we use horizontal perspective. At times we use the vertical perspective. We will see both of them. When to use horizontal perspective, when to use vertical perspective becomes so automatic. All right, now the moment already you look at the questions, already it automatically pops up. Okay, so now the other point, all right, coming to the last point on the similarity of triangles, and then we'll go to the problem solving. The last point here is what? So how do I understand that, man, there is a similarity of triangle? What are the triggers that trigger my mind that, hey, look for similarity in this question? What are the things that you look at? All right, one, presence of parallel lines. Now look for this, presence of parallel lines, not parallel sides. Look for the presence of parallel lines. Yeah, parallel sides is fine. Well, there will be two sides which are parallel or whatever. Presence of parallel line. Okay, second one, presence of common angle. Trigger, all right, put these triggers properly in your mind. All right, the presence of vertically opposite angles. Now it's in that order only. Parallel lines, more often you see parallel lines, then you see common angle, you also see vertically opposite angle. Now these are the parameters that you kind of see. Try to match two angles, automatically the third angle will match. You don't have to worry too much about it, because when two angles of a triangle are equal to two angles of the other triangle, naturally the third angle would be same. Okay, now these are the things I want to keep it in mind. Point number one, let me quickly reiterate what are the points I said. Hey, look, angles are the ones which govern us. The similarity of triangle is governed by angles. Angle becomes the reference point. Then I talked about, once you take the angle as the reference point, the side opposite the angle is the keyword. Then you have the horizontal perspective, you have the vertical perspective. All right, now this is what you get. Either look at the horizontal perspective and compare one triangle with another triangle, or compare the sides. All right, now compare. Horizontal perspective is what? Comparing the triangle versus triangle, right? Vertical perspective is what? Comparing the sides, corresponding sides of the triangle. That's a vertical perspective. Then you have the three triggers: presence of parallel lines, presence of common angle, presence of opposite angle. Now this takes about 3 to 4 months of your study when it comes to the high school, class 8 or class 7, I'm not sure. In one of those class, based on the boards that you study, whatever I said now in 10 minutes or 15 minutes, you study this for about 3 months. You don't believe it? That's the long time that you are going to learn these 4 parameters I spoke about, the similarity of triangles in high school. Great. All right, now that's about the summary of this clearly. Let's go to the problem solving on this. Let's take a look at this particular problem here. Okay, read it to yourself once. Read it to yourself. Read it to yourself once. Right? Okay. So in this given figure, ABCD is a parallelogram, right? You have this parallelogram. So naturally, of course, these sides are also parallel. Okay, ABCD is a parallelogram such that AE is to EB, all right, AE is to EB is 2 is to 3. Okay, if I call this as 2x, then this length is going to be 3x, all right, 3x. And DF is to FC is 7 is to 3. And if I call this as 7y, then this would become 3y. Look, in a parallelogram, let's stop there. Then he wants what? He wants the area of this. Let area of this, that is nothing but EGB. This he calls in the numerator. This is in the numerator divided by area of this, let, which is in the denominator. Let, which is in the denominator. I need to compare the area of these two triangles. Technically, I need to compare the area of these two triangles. That is what the question is all about. Let, this is what I need to be primarily doing in this particular question. Good. Let's take a look at this, my friends. Let's take a look at this particular question clearly. Now look at this. What I know in a parallelogram. In a parallelogram, the opposite sides are equal. Simply put, the opposite sides are equal. Okay, what do you mean by that? Opposite sides are equal. What does it mean to us? Opposite sides are equal means the length of AB, the length of AB will also be equal to the length of CD. AB is equal to CD. All right, now AB, this particular length should also be equal to CD. That's what you mean by the parallelogram, right? So at least the small definitions, you can't say that, okay, hey, you didn't talk about the quadrilateral set. Come on, all right, now don't kid. All right, so that's all right. Basic diagrams we all understand. The opposite sides are already opposite sides are equal. AB is equal to CD. So you are trying to say that 5x is equal to, therefore 5x is equal to 10y. Now from where you are getting that 5x, 2x plus 3x, 7y plus 3y. All right, the 5x is equal to 10y. Therefore x is equal to how much? 2y. So let me substitute x is equal to 2y. If x is equal to 2y, I can write 2x is equal to, here friends, x is equal to 2y. Therefore 2x is equal to how much? 4y. Okay, 3x is equal to how much? All right, 3x is equal to 6y. Okay, 3x is equal to 6y. Good, that's one. So now what did I do? I wrote everything in terms of y. That's my point. There were two different parameters, x and y's. Now I converted everything in terms of y. This is in terms of y, this length is in terms of y, this is in terms of y, and this in terms of y. Everything is in terms of y. Good. Now look at this. So is there a presence of parallel lines? Of course, yes. Now in these two triangles, now come back and focus on our triangles. Now this is a triangle that I need to focus upon. Let's not deviate from the main problem. All right, that's a problem. Hey, are there presence of parallel lines? Of course, these lines are parallel. This line is parallel to this particular line. There is one presence of parallel line. Is there a common angle? I am not finding common angle here. No problem. Is there a vertically opposite angle? Yes. If I call this as theta, then this is also equal to theta. That's a vertically opposite angle. This is a vertically opposite angle. Last class we learned about it. All right, vertically opposite angle. Now look at this, my friends. This is alternate angle. If I call this angle as x, if I call this angle as x, this angle also becomes x. Why? That's an alternate angle. Now, if two angles of one triangle are equal to two angles of the other triangle, then it is nothing but the similar triangle. Why? The third angle would automatically match. Think about it. If I write this particular angle, if I write this particular angle as z, let's say, if I write this particular angle as z, this angle also becomes z. Why? It is nothing but vertically opposite angle. So therefore, angles of one triangle are equal to the angles of the other triangle. So therefore, all at angles of the other triangles, angles of one triangle are equal to angles of the other triangle. Therefore, these two are said to be similar triangles. Okay, in similar triangles, let's come back to the similar triangles. What is one of the similar triangles? One of the similar triangles is EGB. EGB, that's a lower one here. This is triangle EGB, triangle numerator. That's in the numerator. I'm writing it. Triangle EGB is similar to this another triangle I'm interested in. All right, that's in the denominator. All right, there's a numerator, denominator. I'm comparing the two areas, isn't it? Yeah. What is the second triangle that you are talking about? The second triangle that you are talking about is nothing but DGF. Triangle DGF. Are they similar? Of course, yes. These two triangles are similar, right? These two triangles are similar, right? Okay, so now these two triangles are similar. What are the angles that are common here? X is common, angle Y and angle Z. X, Y, and Z. Now, what is the side opposite angle? Sorry, not X, Y, Z. All right, theta, X, and Z. Theta degrees, X degrees, and Z degrees. Okay. What is the side opposite theta in the lower in the triangle? In this triangle EGB, it is 6y. Theta is 6y. Okay. Side opposite theta in the other triangle, that is DGF, that is nothing but 7y. I'm just copying them. There is 6y here and there is a 7y here. Good. Okay. Therefore, what did I get it, my friends? The ratio. The ratio is 6 by 7. The ratio of the sides, corresponding sides, is 6 by 7. The ratio of the corresponding sides is 6 by 7. See that, what is that also trying to say? Which means if you say that the side opposite angle x, what is the side opposite angle x here? The side opposite angle x, I can call this as, all right, now nothing but FG here. FG here. Side opposite of this is nothing but a side opposite angle x is nothing but EG here. This is EG. EG. The side opposite angle side opposite angle x in the DGF triangle, in the DGF triangle. Follow that chalk. All right, that becomes what? FG. All right, that becomes what FG. Now, what is that you are trying to say? FG is also in the ratio 6:7. FG is also in the ratio 6:7. In the sense, if I call this as 6K, all right, if I call this as 6K, all right, if this particular side is 6K, then this particular side is 7K. This particular side is 7K. Here 6:7. You wrote the ratio as 6:7. You can write it as 6K and 7K. Now look at this, guys. How do I find the area of the triangle if I know two sides and an included angle? Included angle. Hey, which is the included angle you're talking about? This Z is the included angle. This Z is the included angle. Area of the triangle. Now look at this area of the triangle EGB. EGB, area of the triangle EGB can be written as half half. All right, you can write this as AB, half AB sine theta. What is that half? All right, one of the sides. Now look at this 6K. I will write this as 6K. Another side, I will write it as 6Y into sine theta. What is the sine of the angle between them? Sine Z. Okay. Now area of the triangle. Area of the triangle DGF. Area of the triangle DGF. How do I write the area of the triangle DGF? Half. All right, half. So I will use this, say, 7K and 7Y. 7K into 7Y and the included angle. What is the included angle, friends? Z. Therefore sine Z. So now what I want here, I wanted the ratio of this. I wanted the ratio of this. Why? Because author is asking the ratio of this. Author is asking ratio. Therefore when I take the ratio, this gets cancelled, the K gets cancelled, Y gets cancelled, sine Z get cancelled. Therefore you will be left with 6 square by 7 square. Therefore you are left with 6 square by 7 square. Okay, now did it remind you something about what you learnt in the schools? Or it's something about what you learnt in the schools? You know that if the ratio of the sides, all right, so this is clear, right? So from 6 square to 7 square, you already had these numbers 6 square and 7 square. But what you learnt in the school says, okay, all right, if the ratio of the sides, if the ratio of the corresponding sides of two similar triangles or A by B, if the ratio of the two corresponding sides of a similar triangle is A by B, ratio of two similar sides, two corresponding sides is A by B, then ratio of their perimeter will also be A by B. Ratio of perimeter is also A by B. Ratio of their in radius will also be A by B. Ratio of their circumradius will also be A by B. It can be in radius, it can be circumradius, that also will be A by B. A ratio of the sum of the medians, ratio of the sum of the medians will also be A by B, because all these are linear parameters. Any linear parameter will be A by B. Whereas if the sides are in the ratio A is to B, then the area will be in the ratio A square by B square. Area will be in the ratio A square by B square. Right? We all know, because area is nothing but what? It's a square function. Therefore, A square by B square. So if I go back to this particular question, all right, if I go back to this particular question, at some stage we already knew. Let me go back to this particular question. If I go back to this particular question, at some stage, all right, now at some stage we knew that, okay, this was theta and this was theta and this angle was X and this angle was X, this angle was Z and this angle was Z. We knew that these two triangles are similar, and we had this as a 6Y and we had this as 7Y. We had this stage. Now it is good enough. We know that these two triangles are similar, and the side opposite theta in the lower triangle, side opposite theta in the lower triangle is 6Y, side opposite theta in the other triangle is 7Y. Therefore the two corresponding sides are 6Y and 7Y. Therefore the ratio of the areas is what? 6Y whole square divided by 7Y whole square. Nothing but 6 square by 7 square. That is nothing but your answer. Your answer is nothing but, for this question, 36 divided by 49. Okay, now I don't have to go through this sine theta, etc., right? Half AB sine theta, not required, because we kind of remember those particular properties. You need to remember those particular properties. Now here I have a list of them. Right, the ratio of the areas of similar triangles is equal to ratio of the square of any two corresponding sides. That's what we meant here, right? The ratio of the areas, right? Two similar triangles, corresponding sides, or it can be corresponding altitudes. Why? Ratio of sides is same as ratio of altitudes. Ratio of sides is same as ratio of medians, therefore corresponding medians. Anything is fine there. Or corresponding angle bisectors, length of angle bisector, that is also fine, because that's what I was telling you, because we know that in similar triangle, this is what happens there, right? Now that's what happens there, right? That's what happens. So because the ratio of the sides is nothing but ratio of medians, ratio of altitudes, ratio of angle bisectors, length of angle bisectors, all of that. Okay, that's what it means to us. Fine. All right, I hope you sufficiently recalled all of them. My idea is not to go back to high school and tell you all those things clearly there. My idea is to make you sufficiently recall some 30% of what you learned in the high school, which is good enough to crack our exam management entrance exams. You really don't have to learn what all you learned in the high school from class 5. I think the first time you come across geometry is in class 5. From class 5 to class 10, 6 years you study geometry, friends. I'm not saying you study only geometry as a chapter exists for 6 years. 6 years you go on to study bit by bit, piece by piece. Right now, all of that, we need 30% of those theorems what we learned there, and that's good enough to crack most of our exams. Great. All right, now, so this concludes my study on similar triangles. Let's do quickly some problem solving. Having understood this, let's do some problem solving. Here we go. A question. Read the question. Keep your book, pen ready. Take a look at some of the parameters. Right, you did that. Fine. The perpendicular dropped from the midpoint of one of the legs of the right angle triangle to the hypotenuse, divides the hypotenuse into two segments of length 3 centimeters and 5 centimeters. Find the length of the shortest leg of the triangle. Good. So what is happening here? If I call this particular length as x, if I call this particular length as x, this is also x. Hey, why did you say that? Because m is the midpoint. Who said? Author only said the perpendicular dropped from the midpoint of one of the legs. I'll add one of the legs. Hey, is this diagram given in the exam? No, you got to, so you are supposed to be drawing that. Okay, so now just to make the class little quicker, I've already drawn the diagram in advance. The diagrams have been put up there. Will this diagram be available in the exam? No. No. All right, so that's another skill that you may have to slowly gradually learn. You just practice it. Drawing diagram is no big deal about it. It's pretty easier. All right, it's easier. Just that all right, now you just have to get into the habit of drawing. Till the time you get into the habit of drawing, it looks like big deal. So once you get into the habit of drawing, you understand that it's no big deal. Drawing diagram is not a big deal at all. So cracking from there is the big deal. Drawing is not a big deal. So I've taken one of the sites. I took AB. I selected AB as one of the sites. I said that okay, I thought take a midpoint of AB, call it as M. I took a midpoint. Then therefore all it, the total length of AB was 2x. Let's say total length was 2x. I made it as x plus x. All right, I made it as x plus x. Great. All right, that has become this. So finally what I have to find out the length of the shortest leg of the triangle, which means either AB. If you think that AB is shortest, tell me what is the length of this. No, I think BC is the shortest, then tell me the length of BC. Either AB or BC is going to be the shortest leg of the triangle. Find out that. That's what author is trying to say. So okay, so now what did you do from here? You drawn a perpendicular. You drawn a perpendicular onto the third side. You are drawn a perpendicular there. Okay, now therefore all it, now the length of one of the segments has become 3. Another segment has become 5. Another segment has become 5. All right, let's keep that in mind. Let's keep that in mind. Okay, now what is common here? The similarity of triangles. Say, where is the similarity? Common angle. Now look at this, friends. Common angle, parallel lines. This is what I asked you to look for. Look for common angle. Look for parallel lines. All right, now things like that. That's what I was trying to tell you there. Now which angle is common, but which are the two similar triangles? I can see it. You may not be able to see it. All right, no, but with practice you will also be able to see it. Shape looks same. Similarity of triangle is what your experience. Sometimes the shape just looks same and tells the story that man, there is a similarity there. Why can't you see it? Once you see it, just ascertain through the angles that yes, it's similar. All right, because sometimes the eye can be all right. No, so our visual observation need not be accurate. All right, more often than not, similarity looks similarity. You have to trust your eyes. But all right, now I cannot trust only my eyes. I need some proof as well. Like I need some proof as well. Therefore, what is a proof? Look for the angles. Look for the angles. Great. All right, now so let me put it something like this. Let me call this particular angle as theta. Let me call this particular angle as theta, and let me call this particular angle as k. Let me call this particular angle as k. Now look at this. Okay, triangle. I'm talking about the triangle APM. I'm talking about the triangle APM. What are the angles of this particular triangle, friends? There is theta. All right, there is k. The AMP. Let me write it. All right, the triangle AMP. All right, triangle AMP. Theta is there. There is a k and there is p. There is 90 and there is 90. All right, that's a right angle triangle. Good. Now take a look at this. Now take a look at the triangle. Take a look at the triangle ACB. Take a look at the triangle ABC or ACB. What are the angles there? Of course, there is a theta there. There is a theta there, and there is a 90 there. Therefore, what should be the third angle? It has to be k. Even if you prove, you will get it as k, because if two angles are matching, the third will automatically match. Where is the choice in the matter? There is no choice in the matter. Now, where is that common? Therefore, all it now. So one trigger was what? This was the common angle. All right, this was the common angle. All right, that was the great trigger in this particular problem. You had a common angle. Because of the common angle, you crack this. You understand that this is a similar triangle. All right, because of the common angle. All right, friends, let us write some of the sides here. Let us write the sides here. Hey, what is the side opposite theta here? Don't know. Side opposite theta, don't know. Leave it. Leave it. Hey, what is the side opposite k here? 3 units. Side is the side opposite k here, 3 units. Write it. What you don't know, leave it. Don't bother too much about the side that you don't know. Right? Side opposite k is 3 units. Well, let k is 3 units. Okay. Side opposite 90, how much? X units. Write it. Because you already took that as x there. Therefore, write it. Well, therefore, write it. No problem. Okay. Now come to the lower. Come to the bigger triangle ABC. Well, come to the bigger triangle. Hey, what is the side opposite theta? What is the side opposite theta? Don't know. Leave it. Don't bother. Okay. What is the side opposite? Side opposite k. Side opposite k is x plus x 2x. X plus x 2x. Side opposite k is 2x. Correct? All right. X plus x. Side opposite k is nothing but the length AB. AB is what? What is the length of AB? 2x. Good. Okay, what is side opposite 90? Side opposite 90 is here. Both of them. 2 plus 5 plus 3, 8 units. Okay, what we know? We know that this ratio has to be same because there are similarity of similar triangles. In similar triangles, ratio of the corresponding sides has to be equal. But what are your references? Remember, your reference has to be angle. Otherwise, you will mess up big time. Take angle as the reference. Write the corresponding sides opposite of them. Then the corresponding sides are equal. Apply the concept of in a similar triangle, the corresponding sides are, yes, ratio of corresponding sides are equal. Apply that ratio of corresponding sides. Great. So therefore, you are trying to say that, man, okay, 2x square, the cross multiply. You are saying that 2x square is equal to 3 into 8. All right. So therefore, x is nothing but 2 root 3. X is nothing but 2 root 3. That's the value of x. X is nothing but 2 root 3. Come back to the diagram now. All right, come back to the diagram. You can find every other side. And then you can close this particular issue. All right, now I'll come to it. What do I mean by closing this particular issue? You will say that this x is nothing but 2 root 3. This x is nothing but 2 root 3. This x is also nothing but 2 root 3. 2 root 3. Therefore, one of the sides, all right, now AB is nothing but how much? AB is nothing but 4 root 3. AB is nothing but 4 root 3. AB is nothing but 4 root 3. Right now, so what is this one here? AB, this is nothing but how much? 8. Now listen to me, my friends. Listen to me. It's a beautiful triangle. It's a beautiful triangle. I said that, hey, in a 30, 60, 90 triangle, the sides are in the ratio 1 is to root 3 is to 2. 1 is to root 3 is to 2. Isn't it triggering your thought? Which means when you got this as 4 root 3, all right, when you are getting this as 4 root 3, isn't it triggering this particular thought? It must trigger your thought. It must trigger your thought. In opposite of 90 degree, what is the opposite of 90 degree here? 8. I can write this as 8. So opposite of 60 degree will be what? 4 root 3. Therefore, what 1 corresponds to? If 2 corresponds to 8, then 1 corresponds to how much? 4. Therefore, you will say that this side is nothing but 4 units. Okay, if that thought of 30, 60, 90 does not come to my mind, apply Pythagorean theorem. If that does not come to your mind, bad luck. What do? Apply Pythagorean theorem. You know this side, which is 4 root 3. Therefore, you find the third side. Third side would become 4. Therefore, his question is, what is the shortest leg of the triangle? Answer, 4 centimeters. Answer is 4 centimeters. The shortest leg is nothing but 4 centimeters for this particular triangle. Simple one. If the thought of 30, 60, 90 comes to your mind, you can close it much faster. Hey, what triggers the thought of 30, 60, 90? Root 3. Because here you have 1 is to root 3 is to 2. The moment you see root 3, 30, 60, 90 should come into your mind. All right, because more often than not, authors will be interested in the Pythagorean triplets or the theorem of 45, 45, 90 triangle or the theorem of 30, 60, 90 triangle. That is their favorite because they believe that using these things, kids will be able to solve the questions quicker and faster and better. All right, that's a whole idea there. Now, that's a beautiful thing about this question. So what we said here, 2 things we use. Number 1, first, all right, now we need to learn to draw this diagram. That's number 1. Once you draw this particular diagram, then we got to identify the similar triangle. I give 3 triggers to identify the similar triangle. One of them is a common angle. One of them is the presence of parallel sides. Well, the other one is the alternate angle or vertically opposite angle, all that stuff. Right now, those angles that I talked about. Angle is the key. Simply put, first preference is to be given to angle. Once you give that angle, all right, now whatever the data is there, use that particular data, apply that ratio of corresponding sides are equal. Then you are closed with that particular one. Here you could have closed even faster, provided you have realized that there is a concept of 30, 60, 90 triangle out here. Right now, these are the beautiful cat questions I'm doing here. Some of them very good ones. All right, very good questions here. Let's take a look at this, my friends. Let's take a look at this particular question. It's a right angle triangle, right angled here. If you ask where is that right angle, it's here. Right, okay, now what is given to me? It is also given to me that AD is perpendicular to BC. Additional information, AD is also perpendicular to BC. He's saying that, okay, why don't you find, all right, why don't you find the values of X and Y? In the exam, it can be just one of them. Tell me the value of X or tell me the value of Y. That's it, it could be. All right, that's why it could be. All right, now listen to me carefully. Listen to me carefully. Do I know the value of, all right, can I find, all right, what is the value of X plus Y? I know the value of X plus Y, which means the entire BC length, this Pythagorean triplet. It is 6 and 8, and therefore this is 10. Which is the triplet you are using? 3, 4, 5. The basic triplet used is 3, 4, 5. Well, that's a basic triplet we are talking about. That's a basic triplet 3, 4, 5. But then you said that, okay, man, this is nothing but 6, 8, and 10. Therefore, 6, 8, and 10. Hey, what is the length of AD from your previous class, my friends? Length of AD from your previous class. The length of AD is nothing but length of two perpendicular legs, that is 6 and 8, divided by hypotenuse. That's the length of AD. All right, well, length of AD, in case you want to find the length of AD, that's how you would have found that. Where did I teach you? I taught you in the previous class. The product of the two perpendicular legs divided by hypotenuse. Therefore, how much is that? 4.8. Therefore, how much is that? 4.8. Good. All right, that's a 4.8. Now think about this, my friends. Think about this. There are three similar triangles here. There are three similar triangles. Oh, is it really three similar triangles? Yes. Now think about this. There are three similar triangles which all right now. So let me take this particular angle as theta. Let me take this particular angle as theta, and let me take this particular let me take this particular angle as k. Now look at the triangle ABC. All right, look at the triangle. Look at the triangle BA. All right, BCA. Look at the triangle BCA. Just look at the triangle BCA. That's the outer triangle. Look at the triangle BCA. What are the angles of the triangle BCA, friends? Theta is the angle, K is the angle, and then 90. All right, theta is the angle, K is the angle, and then 90 is the angle. Okay, 90 is the angle. Hey, what are the sides corresponding to this? Side opposite theta is 8 units. Side opposite K, all right, side opposite K is 6 units. Side opposite 90 is 10 units. Now I will take a horizontal perspective. Hey, why you will take a horizontal perspective? Simple, because all the values are known here. All right, that's the angles of this triangle. Now the angles of this will also match with the triangle. All right, look at the triangle. All right, look at the triangle BAK. All right, BAD should also be same. Why? Because there is a theta here, there is a 90 here, therefore this has to be K. There is no choice in the matter. Therefore you are again talking about theta, K, and D. All right, now that's what you are talking here. Yeah, do I know the length of AD? I just found out the length of AD is nothing but 4.8. You just found out. I can write this 4.8. You can write this 4.8. Yeah, what is that you are trying to say? Therefore here, what is that you are trying to say? The side opposite theta is 4.8. Side opposite theta is 4.8. Side opposite K, all right, side opposite K is what you have to find out, X. Side opposite K is what you have to find out, right? Yeah, X. The side opposite 90, I know that that's equal to 6. That's equal to X. Can I find it out? Yes, because this ratio should match with this particular ratio as well. It has to match with this particular ratio as well. Or in other words, you got to say that, hey, this by this should also be equal to this by this. I can solve it. Therefore, 8 divided by 4.8 is also equal to 6 divided by X. I can put it something like this: 8 times 8.6 times. Therefore X is equal to 6 into 6, which is 3.6. I can plug it. Therefore I can say that, man, the value of X is nothing but 3.6. If the out of 10, if 3.6 is here, out of 10, if 3.6 is here, the remaining length is out here. The remaining length is out here. All right, now that's 3.6 there. All right, 3.6. All right, you are getting that as 3.6. Therefore I can get the remaining length from here, 10 minus 3.6. All right, which would become 6.4. All right, this would become 6.4. All right, you will get the required answer, the required length. Already you are going to get it from there. You are going to get it from there. That's about this particular question. It's such a beautiful question. It is such a beautiful question here, right? That's the meaning of this particular question. There we go to the next one. So what is the perspective that you used? I used the horizontal perspective. It was given. Whether you use vertical perspective, horizontal perspective, don't worry. As long as you understand that there are similar triangles here, the job is done. You might have closed it by using another similar triangle also. Hey man, what is the another similar triangle you are talking about? Now look at this. All right, now this is 90 degrees here. This is 90 degrees. All right, and this is K. If theta 90 degrees and K are two angles, what should be the remaining angle? Theta, because theta, K, 90 are the sum of the angles of the triangle, which is 180 degrees. Therefore, that is theta. So therefore, again, you have another similar triangle here. You could have taken this also and closed it, but I don't need all similar triangles at once. One of them is enough. One of the similar, or let's say a pair of two similar triangles is enough to close this question, right? Yeah, because we know that the sum was 10. Out of 10, if I know one side, I can find the other side. For that, I don't need another similar triangle there. Good. I guess everybody's learning something here. I'm doing the questions straight from the exam, well, because that would help us. That would help us because simple concepts here, simple concepts. Okay, there's another cat question. Take a look at this, friends. Take a look at this, another cat question. Beautiful one. Beautiful one. Another cat question. Another cat question. I guess everybody is learning here. Right, okay, angle B is 90 degree. This is what is given to me. All right, in this particular triangle, angle B is 90 degree. AB is equal to 8. Fine, this entire length outside is 8. Then he's also given that the entire length of BC is 6. The entire length of BC is 6. Therefore, I know that the entire AC length will be 10. The outside, the complete length of AC would be 10. Okay, that would be 10. Now he's saying that find the side of the square. Why don't you find the side of the square? Let me call the side of the square. Let me call the side of the square as x units. Let me call the side of the square as x units. Therefore, this is also x units. This is also x units. So wherever you find, you can write that that's nothing but x units. Good. So what is that I need to find here? X side of the square you have taken as x. Therefore, the idea is what? Find that x then, because you only said that let the side be x units. Therefore, find that x there. Okay, there are similars. There are many. Again, there are three similar triangles here. On the face of it, in this particular diagram, there are three similar triangles. Okay, if I call this particular angle as theta, if this call this angle as theta, and let me call it this is 90 degree. This is 90 degree. Why? Because this angle and this angle are the corresponding angles, right? Now these two are the corresponding angles, that is 90 degree. And let me call this as k. If I call this as k, this is also k. Why? These are again corresponding angles. All right, this k and this k are the corresponding angles which we studied in the last class, or which we studied in the yesterday's class about the angles. Both of them are corresponding angles. Anyway, therefore, all right, now you already got one set. That's good enough for us. You want many more sets, we can, but then is it required? Not necessarily required. Not necessarily required. I'll complete what I meant here. First, on the face of it, let me start with two similar triangles. Hey, what are the angles here, friends? The angles are theta, k, and 90. Angles of a triangle are theta, k, and 90. So which is one of the triangles I'm talking about? I'm talking about the triangle ABC. I'm talking about the triangle ABC. Hey, what is the side opposite theta here? 6 units. What is the side opposite k degrees here? Well, it's k degrees here, 8 units. Which triangle? Triangle ABC, friends. Go to the bigger triangle and identify the sides opposite these angles. Sides opposite these angles. Hey, what is the side opposite 90 here? 10. Therefore, all it now it's a horizontal perspective. I can close this 6, 8, and 10. Okay, whatever I want, let me pick it up. Let me pick it up. All right. So then let me go to triangle. Let me all it now all of you focus on triangle ADE. All of you focus on triangle ADE. Let all of you focus on triangle ADE. If you look at the triangle ADE, the angles are again same there. The angles are again same there. But if I go to the triangle ADE, what do I know? I don't know anything. All right, I just know only one thing. That is the side opposite theta is how much x. Side opposite theta is how much x. Now look at this, friends. Look at this. All right, look at this. Okay, what I know. What I know is this by this. All right, now so all this ratio. What is the ratio of the above triangle? 6 corresponds to x. Therefore, 8 corresponds to how much? 10 corresponds to how much? Why? Horizontal perspective. I'm talking about the horizontal perspective. Look, theta degrees, k degrees, and 90 degrees are in the ratio 3:4:5. Horizontal perspective. I'm talking about 3:4:5. Therefore, if 3 corresponds to x, then 4 corresponds to 4x by 3. Then 5 corresponds to 5x by 3. Simple. That's it. What is the ratio now? All right, what is the ratio now? Multiply this throughout by 3. Multiply this throughout by 3. It will become 3x, 4x, and 5x. Hey, is this ratio same as 3:4:5? Absolutely yes. 3:4:5. Hey, from where you got the 3:4:5? From here, my friends. From here. I am getting it from here. All right, 6, 8, 10 is nothing but what? 3:4:5. Then the corresponding ratio, if I call one of the sides as x, then the corresponding ratio will become this. That's what I'm trying to say here. All right, that's what I'm trying to say here. Therefore, if 6 corresponds to x, all right, 6 corresponds to x, that's what you are trying to say. Okay, or let me simplify this. Ratio of the sides is 3:4:5. I can call it something like this. Now from here, come to the triangle ADE. Come to the triangle ADE. Now the side opposite of this, you are calling it as xy because it's given to me. There is x there. Therefore, 4 corresponds to how much? 4 see, it's like this I'm doing. 3 corresponds to x. Therefore, 4 corresponds to what? How do you write it? All right, now, therefore, you write this as 4x by 3. 5 corresponds to what? 5x by 3. Now, what is that I'm trying to say? This is 4x by 3. This is 5x by 3. This is 5x by 3 if I were to represent this, which means I know one angle, I know one side called x. I can write other sides also in terms of x. That's my point. Why? Because I understand the similarity. Because we understand the similarity, you know one, you can write the other ones. That one is also unknown only. This x is also unknown. That's all right. But you can write the other unknowns, other things in the same unknown. That's my point here. So if you write this much, all right, your job is actually over. Your job is actually over. Now look at this. This side out of 8, this is 4x by 3. And this side it is going to be x. This side it is going to be x. Okay. What I'm trying to say is this. What I'm trying to say is AB, length AB, the side AB here, A to B, is also nothing but AD plus DB. AD plus DB. What is AD? AD is nothing but 4x by 3. AD is nothing but 4x by 3. What is DB? DB is nothing but x. The total is equal to what? AB is how much? 8. Solve it. You will get the value of x from here, right? The value of x from here. All right, value of x from here. Therefore, you will say that 24 is equal to 7x divided by 3. Take 3 common there. All right, now 3 multiply throughout by 3. All right, multiply throughout by, sorry. So what you do is, all right, now, yeah, all right, now 7x, all right, now it becomes, all right, now 24 is equal to 7x. Therefore, x is equal to 24 divided by 7. That's a required answer. That's a required answer. Hey, why that is the required answer? Because that's what I was trying to find out. X is nothing but the side of the square, which is nothing but 24 by 7. All right, 24 by 7, which is about 3 point something. All right, 3 closer to that. All right, 3.5, kind of very close to that. Right, okay, all of you got the perspective on this. Pretty simple one. It's on the similar triangle. All these were CAT questions, what I'm doing. Pretty, all right, no, simple ones. Simple ones provided you understand the concept in the right sense. Are you getting the triggers right? Are you getting the triggers which are common angle? Are you able to figure that out? Common angle, are you able to find out? All right, are you able to find out sometimes all of the parallel sides? All right, things like that. Once you find out those kind of things, once you understand there is a similarity of triangle, shift your attention to angle, you will be able to close the things. All right, you would be able to close the things. Fair enough. Let's take one more. Okay, now before that, all right, we'll take it up to towards the end little later. Let's go to the next theorem, basic proportionality theorem. Basic proportionality theorem. Again, you need to understand this. This is what you learn in the high schools and you conveniently forget as well. What is basic proportionality theorem? What is the trigger? The presence of parallel lines. Presence of parallel lines. That is the trigger. Well, this is the trigger. Trigger for the basic proportionality theorem is presence of parallel lines. You should not forget the trigger. All right, you look at the presence of parallel lines. Proportionality theorem is one thing that comes to your mind. All right, now is it useful or not is a different issue, but that is something that comes to your mind. All right, that is something that comes to your mind. Right, okay, fine. Let's take a look at this. Let me explain the basic proportionality theorem. Assume that the length line DE is parallel to BC. If the line DE is parallel to BC, all right, line DE is parallel to BC. Assume that, okay, now this is the ratio. All right, this is in the ratio of, all right, this is in the ratio 3:2. Assume this ratio is 2. Assume. I'm just giving you some number. AE is to EC is given to us. Assume that AE is to EC is given to us. So a couple of things that we can find out. Listen to me, my friends. AE is to EC. AE is to EC will also be equal to AD is to DB. AD is to DAD. AE is to EC will also be equal to AD is to DB. AD is to DB. Point number one. All right, that's point number one. Also second point here, AE is to, all right, AE is to AC. All right, AE is to AC will also be equal to, no, point number two, AE is to AC will also be equal to DE is to BC. All right, DE is to BC. Now this is the point here. Okay, so why I'm starting with AE is to, all right, AE onwards. Why I'm starting here? Because it's given. Assume it is given. This is how you can write. Assume this is given. That is how you can write. Two things you should remember about the basic proportionality theorem. Given these two sides, you will find the relationship between these two sides. All right, now given these two sides, also given these two, all right, given these two particular sides, you can also find the relationship between these two sides. You can also find the relationship between these two sides. All right, that is precisely my point. Okay, now the extension of this, the midpoint theorem. Extension of this is the midpoint theorem. Midpoint theorem means what? Nobody has to tell us anything. This ratio is 1:1. This ratio is 1:1. Therefore, this ratio is 1:1. The moment you join the midpoint of the sides, naturally the line joining the midpoints. Assume that the D is the midpoint of AB. D is the midpoint of AB, and E is the midpoint of AC. If you join the midpoints, the line joining the midpoints is always parallel to this base. Is always parallel to that particular third line. Always parallel to the third line. By applying the same information, you can say that DE divided by BC Let DE divided by BC, these lines, friend, DE divided by BC would be in the ratio 1:2, would be in the ratio 1:2. Here we didn't know about it. Here we didn't know about DE is to BC because that depends on these numbers. It depends on these numbers. In this question, you can say that this is nothing but 3 divided by 5. 3 divided by 5 because BC, what is the length of BC here? The BC will be corresponding to AC, or corresponding to AC. What is AC here? 3 plus 2, 5. Therefore, you can call this in this question, if I take that example. So here it is always going to be 1:2 because this is 1, this is 1. Therefore, this will be in the ratio 1:1 plus 1, which is 1:2. All right, let's keep this in mind. Now, this is about the basic proportionality theorem or the midpoint theorem. Basic proportionality theorem, a subset of basic proportionality theorem is nothing but the midpoint theorem. What to remember in basic proportionality theorem? Two things. These are the two things. All right, let's assume that, okay, we learned this, all right, we remember this. Let's look at the applications built on this. Let's quickly understand the application built on this. Take a look at this question. I want all of you to take a look at this question. Beautiful question. Beautiful question. Take a look at this. See, it's not just about the theorems, right? It's always about how do I apply them in real time. Yeah, all right, let's do it together. So we need to arrive here. This is what I want ultimately. What is the x and pq are both parallel to BC. Sorry, find the length of PQ. I need to arrive here. I need to come here. I need to arrive at what is the length of PQ. Let's start with the information. The lines are parallel. Firstly, he's saying that look, these three lines are parallel. Right, these three lengths are parallel. Where he said? He said that XY, PQ, both are parallel to BC. So therefore, technically they are parallel. Now, what is given to me? AX and XB are in the ratio 2:3. Good. If this is 2:3, okay, then all I can write is all it did this in the ratio 2:3. All right, therefore, what you will say here, if this length is 2x, all right, if this length is 2x, then this particular length is going to be 5x. How, friends? Because of the basic proportionality theorem applied in the triangle ABC. If I take a look at the triangle ABC, if I take a look at the triangle ABC, and if I apply the basic proportionality theorem here, if this is 2:3, like 2:3, and this length is x and y, you know that, okay, AX divided by AB, AX divided by AB will be in the ratio XY divided by BC, XY divided by BC. Therefore, you write this as 2x and 5y. Okay, but what is given to me? It's also given to me 2x is equal to 14 is given to me. Because the length of xy is 14, that's given to me. 2x is equal to 14. Therefore, what is the value of 5x here? 2x is equal to 14, x is equal to 7. Therefore, you say that, man, this is 35. The length of BC is equal to 35. Good. Let's go to second trigger. Let's go to the another trigger. What is the second trigger given to me? It's given DP and PB are in the ratio 3:4. DP and PB are in the ratio of 3:4. Okay, let me write it. If this is 3, DP is 3, PB is in the ratio 4. Okay, therefore, what you will say here, if this is 3y, if this is 3y, this is going to be 7y. Again, applying the basic proportionality theorem, applying the same basic proportionality theorem. What is 3 plus 4? 7. That's what I will be writing here. If this is 3y, this is going to be 7y, 3y and 7y. Okay, so therefore you got the value, you will get the value of y here. 7y is equal to 35. 7y is equal to 35. Therefore, you get the y is equal to 5. Once you get the y is equal to 5, you can find the value of 3y. That is 3 into 5. Well, that's where you get 3 into 5 here. Right, yeah, so you get the value as 3 into 5. Sorry. Right, you get the value of 3y, which is nothing but 3 into 5. All right, 3 into 5, which is nothing but 15 units. Nothing but 15 units. That's the required answer. Find the value of PQ, which is nothing but 15 units, which is nothing but your answer. Simple one. So what did we apply? We just apply the basic proportionality theorem. Simple. All right, simple. All right, elegant question. Pretty simple one. But if you just don't know the basic proportionality theorem, so this will this will hold you back. Such a simple question can hold you back. Right, yeah, but if you know the basic proportionality theorem, life is simple. Okay, let's go to this one, my friends. Let's go here. Let's take a look at this question. Let's take a look at this particular question. Okay, All right, let's do it together. Now there is a similarity as well here. All right, now A is to EC. Now it's saying that okay, DE, firstly, parallel, presence of parallel lines and presence of common angle. This is theta. Now if I call this angle as X, this is also X corresponding angle. If I call this angle as Y, this is also Y corresponding angle. Okay, now what is he saying? A is to AC is 5 is to 4. He's saying that A is to AC is 5 is to 4. He wants the area of the triangle ADE to ABC. ADE is nothing but 5 square. Take the side opposite angle X. Take the side opposite angle X. Here also take the side opposite angle X. Hey, what is the side opposite angle X? 5 plus 4. 5 plus 4 which will become 9. Let 5 plus 4 which will become 9. Therefore the required answer is 5 square by 9 square. Simply put, the required answer is 5 square by 9 square. Yeah, how do you say this is 5 square by 9 square? We just learned it some time back. We just learned it some time back. In a similar triangle, if the ratio of the corresponding sides is X or corresponding sides is A by B, the areas are A square is to B square. That's what we learned. A square is to B square. That's done. Okay, now the second one is important to us. That was the cat question. The second one, area of ADE divided by. All right, now this time author is interested. Look man, okay, I am interested in this piece. I am interested in this piece. All right, versus this particular piece. That's what he's saying. This particular piece. We don't have the direct way to find it, right? Yeah, numerator is still nothing but 5 square. 5 square, but the denominator is nothing but 9 square minus 5 square. Okay, why 9 square minus 5 square? A triangle can be compared with another triangle, right? One triangle can be compared with a larger triangle. You cannot compare a triangle with a quadrilateral. Therefore a triangle can be compared with a triangle. Therefore first you compare a triangle. Even if the second question was the one which was asked in the exam, you compare a triangle versus a triangle. Then if you say that the upper portion is equivalent of 25 units, then the lower portion is nothing but 81 minus 25 units. Let 81 minus 25 units. Why? Because the entire bigger triangle ABC is nothing but 9 square. That is 81 units. Now what you do? Remove the upper portion out of that, because that's a ratio. Ultimately it's a ratio. It will get cancelled, right? Therefore remove that. You may say that, hey, isn't it 25x is 25k it is going to be? It may be. Don't bother about it. That k will get cancelled here also, right? No, so therefore that's not a worry. Therefore you can directly write as 5 square divided by 9 square minus 5 square, right? 9 minus 5 whole square. All right, that is fine. That is fair enough there. So therefore you can write this as the required answer is nothing but 25 divided by 25. All right, 25 divided by 52. Sorry, 56, right? That becomes your answer there. Fair enough. All right, let's go to the next one. So once, as long as you understand this, let's go to the next one. So here is a beautiful question. Here is a really beautiful cat question. Take a look at this. It's a really beautiful cat question. Okay, all right, let's do it together. In the figure given below, this one, or the figure given below, AB is parallel to CF. He's saying that the line AB is parallel to CF. All right, he's given this. Let's mark the information first. This line and this line are parallel. All right, these two lines are parallel. It's also given that the length BC is similarly is equal to CD, which is also equal to DE. Already equal to DE. What is that author is interested in? He's interested in the area of the triangle DEF, the area of the triangle DEF to the bigger triangle ABA, to the complete larger triangle AB. He is interested in this. What is that hashed portion? This piece. Let this hashed piece versus the total piece. Let hashed piece versus the total piece. That's what he is interested in. Fine, great, good enough. Now let's understand this, friends. Let's understand this. Now listen to me carefully. Now assume as if this line is not given to us. For a time being, assume that okay, man, this line is not given. If line is not given, then this ratio becomes 1 is to 1 is to 1, right? 1 is to 1 is to 1. So which technically becomes 1 is to 2, which becomes 1 is to 2. Okay, you didn't understand? Let me draw a separate diagram for you. This is 1 is to 1 is to 1. You may wonder, hey, suddenly why you are writing 1 is to 1 is to 1? This length is same as this length, which in turn is same as this length. Therefore what? Well, therefore that is nothing but the ratio of these particular sides is 1 is to 1 is to 1. Good. So now let me drop one triangle here. It is something looking like this. I want you to focus on triangle A here, B here, and E here. And then, all right, now this parallel line, which is EF here. All right, FC here. this parallel line. Just I want to look at this. Okay, if this is 1, the other side is 2. Why other side is 2? This and this put together. Hey, what happened to this point D? I removed it for the time being. I removed it. For the time being, I removed it. 1 is to 2. Now apply the basic proportionality theorem, my friends. If you apply the basic proportionality theorem, it is the same thing here. Two parallel lines, presence of parallel lines. If this ratio is 1 is to 2, then this ratio is also 1 is to 2. It's also 1 is to 2. See, dimensions can be different. You may say that, hey, if the length of this is 1x and 2x, I'm not claiming this is 1x and 2x. I'm claiming this should be 1y and 2y. The ratio is 1 is to 2. I'm not claiming that the lengths will be equal. I'm not claiming that the ratio is equal. Why? Because of the basic proportionality theorem, presence of parallel lines. What do you mean by basic proportionality theorem? There must be presence of parallel lines. That is when you will realize this point. Okay, good enough. Therefore, you will say that, man, if I write this as 1x here, 1x here, 1x here, then I'm trying to say this is 1y and this is going to be 2y. Or this particular length is going to be 2y. Same thing, whatever I spoke here, I transferred the data onto the given triangle. I transferred the data onto the given triangle. Now look at this, friends. Now you want the triangle DF. Let me take a common angle here. Let this angle be theta. Let this angle be theta. It's a common angle. I'm not looking for similarity. I just applied the basic proportionality theorem to get this 1y and 2y. I just applied the basic proportionality theorem to arrive at that. Now look at the area of the triangle DEF now. Now let's go to the area of the triangle DEF. All right, area of the triangle EFD. All right, whichever way you call it, DEF or EFD, whichever hashed triangle, half product of product of two adjacent sides, that is 2y and 1x. Let 1x into 2y, 1x into 2y, and the included angle 1x into 2y in the included angle. What is the included angle? Theta, sine theta, half AB sine theta. Dude, that's nothing but area of the triangle DEF. Now think about the area of the triangle. Let's go to area of the triangle. All right, AB, area of the triangle AB, that's the outer triangle, the big one, half. Now look at this. How many x here? 1x plus 1x plus 1x total. All right, because I'm looking at this included angle theta here. Total, what is the length of that leg? 3x. Length of that leg is 3x. 1y and 2y. What is the length? ACAE here, friends? That is 3y. Yeah, what is the included angle between these two sides? Same sine theta. So what I wanted the ratio. Why? Because author only said that get me the ratio. That's enough for me. All right, get me the ratio. Good. All right, therefore I will get this author the ratio. So now x and xy's get cancelled. That is irrelevant. Sine theta get cancelled. All right, half. All right, no. So therefore finally after simplification, what is that you are left with? You are left with 2 divided by 9. That's about this particular question. Hashed region versus the complete triangle, the relationship between them, the area or in the ratio 2:9. 2:9. Such a beautiful question. So what is the first part out here? Basic proportionality theorem. Once you apply basic proportional theorem, remember friends, 5 ways to calculate the area. I told you in the last class. Hey, half AB sine theta is your friend. Remember, just because that fellow comes as a sine theta, don't ignore that fellow. Even all it more often than not, the sine theta fellow get cancelled like this. That sine theta fellow get cancelled like this. But half AB sine theta is very, very important. All right, product of two sides, two adjacent sides and an included angle is very, very important proposition for us. You started realizing that. All right, you don't. All right, I told you 5 angles of sine, cos, tan. You should remember that is sine 0, sine 30, sine 45, sine 60 and sine 90. Similarly for the same 5 angles for cos and tan, right, that you need to remember. And that's it. All right, then you will be comfortable using half AB sine theta kind of. Right, okay, good. Let's go further. I guess everybody's learning something. Let's go further. Let's take a look at this. Another beautiful question. After this, we'll go to angle bisector theorem. Another theorem we'll go to. Let's do this question. Okay, now this is not basic proportionality theorem. All right, this is not on that. You might have realized from the previous chapter. All right, now this is based on what? This is based on Apollonius theorem. Apollonius theorem. I told you while I was doing the while I was talking about the centroid medians, right? While I was doing about it, I talked about this. 2 things I said about this particular theorem. So if I have to take one of them as the reference point, if I take A as my reference point, all measurements from A, that is AB square, plus AC square is also nothing but 2 times of the median. This median, right? This is the median. The square of the median, that is AD square plus the third side, that is BC divided by 2 whole square. Third side. third side. Now A is the reference point, write with A as the reference point those two sides, AB square plus AC square is nothing but this. Also I spoke about this, I spoke another important point there, which typically they keep asking in the exam. So AB square plus AC square plus BC square. What are these? These are the squares of the sides. Now this side and this side and this entire side. This entire side is also nothing but if I drop them, AD is a median, let's say, then you can drop another median here. You can drop another median to this midpoint. Let me call it as B square. B, and you can drop another median which passes through the centroid. Assume that this is CF. This is the midpoint. This is the midpoint of this particular side. You also know that, okay, 3 times of the side squares of the sides, 3 times of the sides of the squares is nothing but 4 times of the squares of the medians. That is nothing but AD square. That's nothing but AD square plus B square plus B square plus CF square plus CF square. This is another relationship that you got to be holding on to. This is another relationship that you should hold on to. Just keep these two things in mind, at least with respect to this. If you know that, you would have applied on this and you would have got this particular response. All right, whatever is required in this question, all right, you would have got the response to this. Let's go back to the question. All right, these are the two things I told you already in the previous class. Keep that in your mind. Let's go back. All right, let's go back. Looking at this. Yeah. So what is given to me? It is given to me that AD is 16. All right, median is given to me as 16. It's given to me that AB is 21. It's given that AC is 13. Let AC is 13. Therefore, find the length of BC. Find the length of BC. You can apply it here. I can just apply this here. So you would say that 21 square plus 13 square is equal to 2 times of AD square. That is nothing but 16 square plus BC divided by 2 whole square. I think this 2 I wrote it outside. It's inside. BC by 2 whole square. BC by 2 whole square. Right, BC by 2 whole square. You can substitute, thereby you can get the answer. There is no big deal about it, right? Yeah, proof comes from the cosine rule. Proof comes from cosine rule. Towards the end of this lecture, I will brief you about that. Yeah, what is this cosine rule? Towards the end of it, I'm going to talk about it. It is not that I'm not going to talk about it. I am going to talk about the cosine rule and sine rule as well, because that's important for us. For now, the proof of this Apollonius theorem comes from the cosine rule. Just keep that in mind. Just keep that in mind. Okay, that's another theorem. I'm not taking too many examples built on this particular theorem. Only 2 points are important. As long as you understand that this is point number 1, this is point number 2, keep these 2 points in your mind. We are fairly sorted. We are fairly sorted with that. Let me go to another important theorem, which is angle bisector theorem. Let me go to this, one of the important theorems, which is angle bisector theorem. Let's take a look at this. All right, let's take a look at this angle bisector theorem. What does it mean to us? What does it say to us? So in an angle bisector theorem, again, you have to take it as a reference point. Say that B is the reference point. Hey, why you are saying B is the reference point? Why not A as the reference point? In this diagram, angle B is bisected. Therefore, B is the reference point. Therefore, B is the reference point, because you should know how to write the elements of the theorem. Well, that's very important there. How to write the elements of theorem is important, okay? Because for that, you need to know what I should take it as the reference. Otherwise, you'll be lost, all right? So now why B is the reference point in this? Because that is the angle which is getting bisected. Very good. So now what I should do? So you should write BA divided by BC. BA divided by BC is also equal to, now listen friends, you stopped at A, right? You stopped at A, right? Right from A onwards. If from A, where should I go back? No, don't go back. If you don't go back, there is no point. Go forward. AE. All right, therefore it is nothing but A divided by A. Where did you stop this here? C, right? Now C, okay. From C, where should I go back? No, don't go back. No point going back. Writing it equal, what does it yield? Nothing. So from C, come this side. All right, now CE. That's why you're writing it as CE. Hey, what is this point T? Wherever this angle bisector means what? If this angle is X, this also angle is also X. Wherever that angle bisector is meeting the third line. Wherever that angle bisector is meeting the third line. All right, EC, that is meeting at what? E. All right, that's what the point you're using here. Simple. All right, simple theorem. That's it. All right, that's it. Simple theorem. No big deal about it. If the angle gets bisected, this is the ratio. This is called as the angle bisector theorem. Using angle bisector theorem, you relate what? You relate the dimensions of sides. You relate the dimensions of sides. Okay, let me take another quick diagram for you, just to help you to understand. Let me just take another diagram. Let's say that, okay, so here I'm writing it PQR. I'm writing it as PQR. Angle P is bisected. Let's say that, man, okay, angle P is bisected. Angle P is bisected and it meets at a point called S. It meets at a point called S, let's say. It meets at a point called X. Angle P is bisected. I'm telling you angle P is bisected. How to write the angle bisector theorem on this? Simple. All right, now you got to take this as the reference point. You got to take this as the reference point. Write down these two sides. Write down these two sides. Therefore, PQ divided by PR. PQ divided by PR. Okay, you are at Q now. You are at Q. Just start the journey from Q. Q towards what? Yes. Divided by. Okay, you are at R now. R towards what? R towards S. R towards S. Now this is about the angle bisector theorem. In the sense, okay, once you know that which angle is bisected, take that vertex as the reference vertex, and then you know that how to write the remaining elements. Okay, what does the angle bisector theorem does? It relates the dimensions of the sides. It relates the dimensions of the sides of the triangle. That is what it technically does. Good. I hope all of you got this. Now technically this is called as the interior angle bisector, because what did I bisect here? The inside angle. What did I bisect here? The inside angle. The interior angle is what I bisected. Can there be exterior angle bisector? Why not? Of course, yes. Exterior angle bisector. Let's take a look at this. Exterior angle bisector. Both are equally important. You get questions based on interior angle bisector. You get questions based on exterior angle bisector. Both are equally important. There is no difference between the two. Both are precisely same. Okay. Now, what is the reference point here, my friends? B is the reference point. Yeah, why you are calling B as the reference point? Because exterior angle B got bisected. Exterior angle B got bisected. That's it. Exterior angle B got bisected. Now, therefore, what is the third side here? From B, what are the two sides? BA is one side. Then BC is another side. So technically, you will say that, okay, I will write BA divided by BC. Good, BA divided by BC. Now, look at this. This angle is going on outside here like this. Now, how does it meet the third side AC? It does not meet this third side AC. Therefore, what you will do? Extend this third side AC also. Extend it. So it meets exteriorly at a point called E. All right, it meets somewhere called as E. Simple, friends. You are at A now. A from where? From A, where I should go? From A, should I go back to B, or should I go back to another side? Yes, you got to from A. You got to travel to that particular point where it has bisected the extended line, the angle bisector. This is a line of angle bisector. The line of angle bisector has bisected the extended line AC there. So therefore, AE divided by what? Okay, you are at C here. You are at C. Start the journey from C towards what? Towards that point called as E. Towards that point called as E. Simple. All right, now that's precisely the same theorem. Absolutely no difference. It's precisely the same theorem. Okay, let me just write another triangle for you. Let me just write another triangle for you. And let's say that, okay, this exterior angle P is bisected. Let me write PQR. Let's say that exterior angle P is bisected. Let me have a proposition like this. Let exterior angle P is bisected. PQR is a triangle. Alright, in triangle PQR, the exterior angle P is bisected. Okay, that's the exterior angle here. Let's say that this is what got bisected. Alright, in the sense, if this is X, this angle is also X. Exterior angle P got bisected. Alright, so now what you got to do? Extend this line, extend this line. Now this comes and meets at a point called E here. Let's say this is the point S here. Let's say this is the point S. It's meeting at a point called S. This meeting at a point called S. It's meeting at a point called S. Therefore, how do you write it, friends? Again, P as the reference. Take P as the reference. You will take P as the reference. P towards Q, P towards R. Therefore, PQ divided by PR. PQ divided by PR is also equal to, okay, you are at Q. From Q, where you need to travel towards S. All right, therefore QS. From Q you travel there, QS. From P you got to travel towards what? S. Therefore you are saying that, all right, now from R here you are traveling towards S. That's it. All right, that's it. That's a way to write this particular theorem. That's it. Once you know how to write this theorem, no big deal about it. I guess both of you, all of you would have understood both the theorems, all right, both interior as well as exterior angle bisector theorems. All right, all of you would have understood this. Here is a cat question. Let's take a look at this. Take up this particular question. Let's understand this, dear friends. Let's understand this beautiful question. Here is a question for us. Let's take a look. Yeah, good. All right, here we go. In the given figure below, angle A and angle B are bisected. Okay, let me represent that first. Let us say that, okay, if this angle is X, author is saying this angle is also X, whatever that, it got bisected. Angle B also got bisected. Such a direct trigger. Angle bisector theorem is one of the easiest one to realize. Therefore, I didn't say any trigger here. Angle is bisected is the direct proof of it. Well, angle bisected is the direct proof of it, right? Yeah, okay. So therefore, he's saying that the length of AB is how? Length of AB given to me 12 units. Length of BC given to me, which is 15 units. Total length. Length of BC given to me 15 units. Length of AC given to me, which is 18 units. Right, length of AC given to me 18 units. What is that author is interested? BI and IE. Here is the point I. BI and IE. That is what author is precisely interested in. He's saying that why don't you tell me? I'll let that particular. I'll let know that particular angle. Good. Let me apply the angle bisector at B first. Let me apply the angle bisector at B first. All right, now you can. I'm applying at B first. Okay. So therefore, all right. Now, so what you say? B towards this side and B towards this side. In the sense, you are trying to say that BA divided by, because I'm approaching the angle bisector at B first, BA divided by BC, BA divided by BC. In triangle ABC I'm talking, friends, in triangle ABC, all right, I'm talking about the triangle ABC. I'm applying the angle bisector theorem at point B, at point B. Therefore, BA divided by BC. Continue your journey from A, my friends. Continue your journey from A. So A towards what? A towards E. Therefore, that's also equal to AE divided by C. AE divided by C. Continue your journey from C. C. This is what you mean by writing the angle bisector theorem. Apply. What is the length of BA, friends? Length of BA is 12 units. What is the length of BC? I know that is 15 units. Therefore, AE and CE are in the ratio. AE and CE are in the ratio 4:5. 4:5. Yeah, but what is the length of AE plus CE? What is the length of AE plus CE? AE plus CE is equal to 18 units here. This is the 18 units. AE plus CE is nothing but 18 units. So AE is of the form 4x, then CE is of the 5x. That's equal to 18. Therefore, 9x is equal to 18. Therefore, x is equal to 2. So you are getting these dimensions. Therefore, this is nothing but 5x. That's what you said. This is 5x. 5x is nothing but 10 units. All right. What is this here? You said this as 4x. 4x is nothing but 18 units. What you are trying to say? This 18 is split into two parts. 18 is split into two parts. 8 on one side, 10 on the other side. Simple calculation. 8 on one side, 10 on other side. Good. Solid. That's what the point E is trying to do. Point E is trying to split this 18 units into 8 and 10 units. 8 units on one side and 10 units on the other side. 10 units on the other side. Very good. So let's go further. Let's apply the angle bisector theorem in another triangle. Let's now take a look at the triangle ABE. Look at the triangle ABE. Let's go to triangle A, B, and E. All right, that triangle. So again, angle A is bisected here. Which triangle, friends? Only ABE. So I'm circling them. A is there, B is there, and E is there. Triangle A. All right, point A is the reference. Therefore, write it AB. All right, in triangle AB divided by AE. Don't go till C, my friends. AE. All right, AB divided by AE is also equal to. All right, is also equal to. From B, start going towards this point I. Start going towards this point I. All right, that's nothing but BI. All right, now from E. All right, now you are going towards EI. All right, this is the angle bisector theorem applied on this. Well, this is what you are applying on this angle bisector theorem. Simply applied on this becomes this. Substitute the values. What is the length of AB here? Substitute. AB is 12 units. What is the length of AE? 8 units. All right, that is nothing but BI divided by EI. So therefore, you are saying that this is nothing but 3/2. All right, that's nothing but 3/2 or 3:2. That's your answer. All right, that's your answer. 4 3 times and 4 2 times. That's your answer. 3:2 is the required answer. Beautiful question. Beautiful question. What did we do? Nothing. 2 times we applied the angle bisector theorem. That's all we did. All right, 2 times we applied the angle bisector theorem and we got our response. All right, we got our response. Just learn to work with the theorems that you know. I'm directly taking some of the CAT questions so that you kind of understand how we are relating it, all right, with respect to CAT questions. Now, this is the difficulty level of 50% of the geometry CAT questions. 50% of them in the core geometry belongs to this difficulty level. They don't get tougher than this. All right, now remaining of them will be much easier than this. I'm saying this is the median level questions I'm talking about. Some of them will be little above median, some of them would be little below median, but this is the median. If you can set at this particular median, trust me, you can do 3 out of 5 questions. 3 out of 5 questions. Only thing is, will not be able to relate and apply the concept. That's a problem. Comes by little practice. Geometry is a simple subject, comes by little practice. Okay, here we go, another one. Here we go, another beautiful question. Here we go. Check this out. Right? Okay. So what is given to me? AB is 10 units. Given to me, AB is 10 units. BC is 15 units. BC is 15 units. Right? And then he's saying that AD is to DC. All right, AD is to DC is 2/2:3. That is 2x. Therefore, this is entire thing is going to be 3x. Hey, why can't I see so directly here? This 10 and there is a 2x here, this 15 and there is a 3x here, or a 10 and 15. Okay, you didn't get it? Let me explain that. Okay, assume that this angle is theta and this angle is theta. Apply angle bisector theorem at B. Apply angle bisector theorem at B. BA divided by BC. BA divided by BC is nothing but AD divided by CD. Isn't it? Both are same here. 10 by 15 is equal to 2x by 3x. Both are equal. Both are equal means what? These angles has to be equal. If the unless these angles are equal, that relationship will not be true. That relationship will not be true. Now this is a reverse of what we are trying to think, isn't it? This is just the reverse of the way we are trying to think. Therefore, I need to keep my eyes and ears open to the stimulus that has been said. Be open about the numbers. Don't close them off. Don't close them off. Be open to the numbers, because you are seeing a 10 here and you are seeing a 2x here. You are seeing a 15 here and you are seeing a 3x here. Can't I see that relationship? 10 corresponds to 2x, therefore 15 corresponds to 3x. The ratio is same. If the ratio is same, then this particular angle is bisected. Angle B is bisected. Without being angle B bisected, that ratio will not be true. Alright, therefore we are applying the angle bisector theorem. This theta I know. I can talk about this particular triangle. This particular theta we know. This is 130 and this is 30. Therefore that's 160. Therefore this is 20 degrees. If this is 20 degrees, then I know that this is also going to be 20 degrees. Therefore the required angle ABC is nothing but 20 plus 20, which is nothing but 40 degrees. 20 which is nothing but 40 degrees. Simple one. Such a beautiful and elegant question. An elegant question. The point is what? You need to relate the numbers after knowing certain theorems, etc. If you can't relate, then we fumble. Alright, we got to relate the numbers. Alright, we got to relate the numbers. Great guys. Alright, now here we go. Alright, now that completes my theorems, etc., etc. Now I'm going to open up the questions. Probably I will do about 10 odd questions. Let's try and see how much ever is possible in the next 30 minutes. Let's solve some questions and then we will close the lecture. Because with this my triangles is done. Whatever the basic properties, etc., I need to tell about the triangles. I made more those points. Whatever the points I made, if you remember at least these particular points what I made in my first lecture and this lecture put together on the triangles, you will do a world of good. That's good enough for management entrance exams. Only point is what? How do I apply these points is important. So when I come in my next lecture, of course I will speak to you about what are the things you should remember in quadrilaterals. In the subsequent lecture I will talk about what are the things you should remember from the circles, because all right, if you go to high school it is really voluminous. I can't afford all it now to revise that entire stuff and remember, not required. So we know that okay, about 30 to 40% is all we need to know, and that's what I'm trying to find. That's what I'm trying to handpick and present it in front of you. That's what I'm trying to do out here. Fine. So I presented all that is required from the triangle perspective. Now what I do, I mix all these things. All right, let's mix all these things, and there are few elements that I add. All right, because everything is not over. By and large, it's over, but there are some small elements there. I did not talk about the sine rule. I did not talk about cosine rule, isn't it? I said that I will speak to you later because that's a secondary importance. But yes, it is an important. It's a secondary important, but is it important? Yes. All right, but there is a primary, secondary. I'm saying it is secondary importance, but it is required. I cannot ignore that. All right, to build the speed and momentum, it is required. Now, these are the small things that I'll be talking about it in the next 30 minutes of my lecture. Here we go. Let's take up a look at this particular question here. Let's take a look at this question. Let's take a look at this question. External bisector of angle B and angle C of triangle ABC meet at point O. Angle A is 80 degrees. Then find the angle BOC. Okay, now listen to this. I spoke to you in one of the classes that, hey, there is something called as Excenter. In the last set class, I said there are 5 centers. Right, one of the centers is centroid. Then we talked about incenter. We talked about circumcenter. We also talked about the orthocenter. What we did not talk about the excenter or exocenter, whichever way you call it, excenter. Now this question is built upon the excenter. Technically, what do you mean by the excenter? Let me explain that to you first. If I have a triangle ABC, listen to me very carefully, friends. Listen to me very carefully. ABC. Take the triangle ABC. Extend this. Extend angle B and extend side B and side AB and side AC. Extend this. I'll extend these particular sides. Let's say that okay, I have extended this. Once you extend this, take the interior angle bisector A. Take the interior angle bisector A. Which angle? Interior angle bisector A. Good. So I took this as X. What did I do? Interior angle bisector A. And then take the exterior angle bisector at B. Take the exterior angle bisector at B, that is Y and Y. Exterior angle bisector. Remember, what is that? Exterior angle bisector. Okay. And then you take the exterior angle bisector at C. take the exterior angle. This is an exterior angle. Therefore, this is Z and this is Z. One interior angle and two exterior angle. That gives me a center called as exocenter. That gives me a center called as exocenter. This is called as an exocenter. One interior angle and two exterior angles. Let me call this as exocenter as E. Okay, so how to find an exocenter? One interior angle bisector and two exterior angle bisector. That's a point I wanted to remember. One interior angle bisector and two exterior angle bisector gives me an exocenter. Say, what is the importance of exocenter? Where is that circle, man, by taking the exocenter? Yes. Now, this is where you drop a circle. This as the center. You can draw a circle which will be tangential, all right, which would be tangential to these points, which will be tangential to these points. Now, this is the exoradius. This is the radius of the exocenter, whatever you call it as r dash or whatever you want to call it, you call it. That is the radius. Using that radius, you can draw a circle which will be tangential to this side, which will be tangential to this extended side, and which will be tangential to this extended side. This is called as the exocenter. Now, the point, you may say that, okay, which interior angle I should take and which two exterior angle you should take, anything. You will have three exocenters. You will have three exocenters. In the sense, hey, had I taken the interior angle bisector of B and the exterior angle, you would have got another exocenter on this side. From here, you would have dropped a circle. From here, you would have dropped a circle. Simple like that. Therefore, for a such particular triangle, there will be three exocenters possible. All right, now remember, for any triangle, there is only one centroid, there is only one incenter, there is only one circumcenter, and there is only one orthocenter. But for any triangle, there will be three excenters, three exocenters. There will be three. All right, I've shown one of them. Okay, my point here is what? What did I show it to you? So I said that one, the exocenter is nothing but point of intersection of one interior angle bisector and two exterior angle bisector. Two exterior angle bisectors. Good. I got this. Now listen, again, I have a vertical angle here. Again, I have a vertical angle here. Now listen, this particular angle here. Listen to this carefully. Let me remove this. Okay, let me remove this circle for the time being. Okay, now this is called as a vertical angle. This is called as the vertical angle. Now this vertical angle, this particular angle, all right, vertical angle theta, this vertical angle theta is related with this particular angle here. Angle A is related with this particular angle A. Okay, how it is related? Angle BEC, angle BEC, called theta in our language here, angle BEC is nothing but 90 degrees minus angle A by 2. 90 degrees minus angle A by 2. Angle BEC is nothing but 90 degrees minus angle A by 2. Okay, same way out here, my friends. Same way out here. He is talking about the angle BOC here. He's simply talking about the angle BOC here. Why? Exterior angle B and C are bisected. Exterior angle A are bisected. Okay, if this is theta, this is also theta. If this is angle X, then this is also angle X. Right now, that's fine. Wherever two exterior angle bisectors are meeting, the interior angle bisector also will meet. You can't say that, oh no, this line is going somewhere else. If it is going somewhere else, then that is not the exocenter at all. Wherever two exterior angle bisectors are meeting, if you are interested to draw this particular line, it will pass through the same line. Already it will pass through the same line. If this angle is y, this angle also would be equal to y. The proofs exist. The proofs are pretty simple here, but I wanted to talk about the exocenter through this example. So therefore you will say that angle BOC, well, therefore the angle BOC, that's what author is interested in. Angle BOC is nothing but 90 minus angle A divided by 2. 90 minus angle A divided by 2. Okay, therefore this is 90 minus, what is the angle A, my friends? 80 degrees. Author is saying that, look, this is 80 degrees. 80 divided by 2, that is 40, which would become 50 degrees. Simple. That's about the story of exocenter. Exocenter is also made up of angle bisectors, but one interior angle bisector and two exterior angle bisector. I want you to remember this angular, all right, study. All right, I want to remember this angular study on this. I want you to remember this. All right, this I want to remember about this particular angle. 90 minus A by 2. So whereas the interior angle in center, what was the in center there? It was plus, isn't it? This is 90 plus. That's how you used to write there. Instead of plus, you have to just write minus here. You have to just write minus here. Good. I think all of you got this minor point here. All of you got this minor point here. Let's go further. Let's go further. Take a look at this cat question. Take a look at this cat question, all of you. Yeah, okay. Triangle ABC is a right angled at B. It is right angled at B. AC is equal to 12 units. Angle ACB is 30 degrees, right? And we have drawn the figure here already. This is 30 degrees, right? Given this is 30, this is 60, therefore this is 90. Technically, you are trying to say that ABC is a 30, 60, 90 triangle. That's the first point. All right, triangle ABC. All right, if you just look at the triangle ABC, my triangle ABC is a 30, 60, 90 triangle. If it is a 30, 60, 90 triangle, the sides are in the ratio 1 is to root 3 is to 2. All right, root 3 is to 2. What is given to me? So side opposite of root 2 is given to me, that is 12 units. That's given 12 units. Therefore, can I write the side opposite of 30 degrees? Yes, side opposite 30 degrees is going to be 6 units. Well, that's 1 corresponds to 6 units. Root 3 corresponds to 6 root 3 units. Good. Therefore, you will say that entire of this particular length, side opposite 60 degrees is going to be 6 root 3. Good. That's going to be 6 root 3. All right, friends. What is this OD technically? In radius. OD is nothing but in radius. What is OE here? That's also in radius. Therefore, all these lengths, if OD is equal to, all right, now here we know that OD is also equal to EB. All right, because it's a square now. Technically, this has become a square. All right, you can't say that it will be very different from that, right? Now, therefore, it's a square. OD is equal to ED or ED. Similarly, OE is also equal to. Similarly, OE is also equal to DB. All right, here these two lines are also will be equal. So therefore, it's a square. If it is a square, what is the diameter of this particular square? What is the, all right, what is the diagonal of this particular square? All right, now so you will say that what is this OB here? Therefore, OB is equal to R root 2. R root 2. Therefore, this question is about what? This question all it because he's asking that why don't you find the length of OB? That's all he's saying. Hey, length OB is nothing but R root 2. OB is nothing but R root 2. If R root 2 means what is the question mark here? Technically, this question is about find the in radius. If you find the in radius, your job is done. If you find the in radius, your job is done. All right, correct. We know our job is done if I find the in radius. How do you find the in radius? We know that in radius is nothing but the semi perimeter minus hypotenuse. Minus hypotenuse. Hey, do I know the length of hypotenuse? Yes, it is 12 units. Therefore, R is equal to, what is semi perimeter? Semi perimeter is nothing but sum of all these sides. Sum of all these sides, that is 6 plus 6 root 3 plus 12. 6 plus 6 root 3 plus 12 divided by 2. Well, divided by 2 semi perimeter minus what? Minus hypotenuse, which is nothing but 12. Okay, let's simplify this. All right, let's simplify this. All right, that's 9. All right, therefore you will say that 9 plus 3 root 3. 9 plus 3 root 3 minus 12. Okay, therefore radius in radius is nothing but 3 root 3 minus 3. 3 root 3 minus 3. Good. Okay, come back and substitute. You got your answer. You come back and substitute. R root 2 is your answer. Did I get this R value here? Yes, that is 3 root 3 minus 3 times of root 2. Minus 3 times of root 2. That's your answer. Based on the way already has given the answer response, based on the way he has given the answer option, we can find that out. Okay, my point here is what? Look, two things out here in this particular cat question. One is about being educated about the 30, 60, 90 triangle. You will get it easily. Once you know that in radius is nothing but semi perimeter minus hypotenuse, you are done. You are done with your job. Technically, you are done with your job. Just be aware of all its certain fundamental principles here. So within no time, you will be able to close this question. Okay, so it's no rocket science that to realize that it's a square here. In radius is a square here. The trigger will automatically come. All at once that comes, you know that okay, find the in radius and you are done with your job. You are done with your job. Let's go to the next one, friends. Let's go to the next one. Another 20 minutes. 20 minutes. Let me add some values here. Look at this question. Beautiful question. I will speak about cosine rule in this question. Take a look. Take a look at this question, all of you. Try and understand this question. Right? Okay, now let me take a look like this. Okay, what's this cosine rule? First, let me brief you about the cosine rule. Listen, all of you, listen carefully. First, let me brief you about cosine rule. All right, and then what does cosine rule does? Let's understand that and then we'll go further. Assume that if this is A, this is B, and the included angle theta is given, and there is a C. All right, now AB, and there is an included angle C. Therefore, you can say, using the cosine rule, you can say C square is equal to, therefore C square is equal to A square plus B square minus 2AB cos theta. 2AB cos theta. Why? Theta is the included angle between A and B. Alright, therefore you can say that the side opposite that included angle, that is C square, can be written as, can be expressed in terms of A and B. That is A square plus B square minus 2ab cos theta. All right, a square b square minus 2ab cos theta. That's how you technically write this. That's how you technically write this. Okay, let's come back to this question. Let's come back to this question. Where are my elements here? How do I apply this? See, using that, this becomes very easy. Otherwise, what you do in this question, you'll do a construction here. You do some construction 90 degree. You waste unnecessarily some time out there. All that is not required, because that's where I say that sometimes to bring the effectiveness and the speed, it's good to know certain rules, right? So this cosine rule will help you. Big deal out here. So okay, now what is he interested in? AD divided by, already AD divided by DB. He is interested in, okay, tell me what is AD divided by DB. Already AD divided by B, AD divided by AB. Alright, AD divided by AB. This by this, what is the relationship? That's what author is interested. Now listen to me, friends. Take a look at this 1 by 3 here. Alright, BD is equal to 1/3 of BC. Now therefore, why not let me call BC is equal to assumption, because anyway ultimately you want a ratio. So therefore it does not make a difference, because it is something divided by something, whatever you assume in terms of that. You may say that BC is equal to 3 units. Let me call BC is equal to 3 units. Hey, why 3 units? Why not 2 units? Because it is 1 by 3. Because it is 1 by 3, let BC is equal to 3 units. Therefore, BD is equal to, I made an assumption, let the length of BC is equal to 3 units. Then the length of BD becomes 1/3 of 3 units, which will become 1 unit. Therefore, this is 1 unit, my friends. All right, this is 1 unit. Yeah, what is the length of AB? Therefore, this is 3 units. This is also 3 units. The entire outer length is nothing but 3 units. That's also nothing but 3 units. So why you are saying so? Because it's an equilateral triangle. Equilateral triangle. If you assume BC is equal to 3 units, then every other length is also equal to 3 units. Good. So therefore, all it knows. So I have to find out. Therefore, what is this AD? Good. What I know this included angle 60 degrees here. I know this is equal to 60 degrees. I know two sides. There is 3 here. There is 1 here. I need to find this. Therefore, let me call this as C here. Or let this be equal to A here. And let this be equal to B here. So I know A, B and the included angle. Can I find the value of C from here? Of course, you can find the value of C from here. Let me find out. Therefore, C square is equal to, what is A square? 3 square. What is B square? 1 square. Minus 2 into 3 into 1 into cos theta. Into cos theta. What is theta here? Well, cos of angle 60. What is cos 60? Cos 60 is nothing but half. Therefore, C square is equal to 9 plus 1 minus 2 into 3 into cos 60 is nothing but half, my friends, right? Cos 60 is nothing but half. All right, therefore, this gets cut off. Therefore, you will say that C square is equal to 7. Therefore, C is equal to root 7. So, you are trying to say that the value of C is going to be root 7. Well, this is going to be root 7. If this is root 7, this is 3. Therefore, the required answer is root 7 is to 3. That is the length of, that's the value of AD is to AB. Such a simple question. If you know the cosine rule, you will close this question within no time without doing too much of construction. You kind of close this particular question. I hope everybody is digesting this. I hope you are digesting what I'm trying to say, right? You are digesting it. I'm assuming that you are digesting what I'm trying to say. That's about the cosine rule. All that application, one of the application of cosine rule in the CAT question. Application of a cosine rule. Okay, let's take a look at this. I will brief you about the sine rule here. I'll brief you about the sine rule. Without sine rule also you can do. My point is here what? Hey, you got to know them. If you know them, you will be able to do them better. That's my point. You'll be able to do them better and faster. Okay, I will brief you about sine rule in this question. Take a look at this question first. I'm not saying that these questions cannot be done without doing sine rule, cosine rule. You can, but that just takes a little more time. That's it. In some critical questions, you can't even avoid sine rule and cosine rule, right? In these questions, you may well avoid, but in some questions, you just can't. All right, fine. Let's come back to this question. In triangle ABC, well, at angle B is 135 degrees. Angle B is 135 degrees, right? Okay. AB is equal to 15 units. BC is equal to 12 units. All right, then find the area of the triangle ABC. Find the area of the triangle ABC. Simple, guys. Area of the triangle ABC. Okay, sine rule is not required here. All right, no, because AB is given to me and BC is given to me. Find the area of the triangle ABC. Area of the triangle ABC is what? Half AB sine theta. Sorry, sine rule will take some other question later. AB sine of the angle between them. Half AB sine theta. So all it that's what you will use for the area. Area is equal to half. Okay, what is A here? A is nothing but 15. What is B? 12. What is it here? Sine of 135 degrees. Okay, now you might not know what is sine of 135 degrees, but I want you to go back to your basic trigonometry you learned in class 10, right? Basic trigonometry you learned in class 10. Sine theta is also equal to sine 180 minus theta. Sine 180 minus theta, where theta is an acute angle, right? Isn't it? Sine theta can also be written as sine 180 minus theta. Nothing but you can write sine 135. You can write write sine 135, all right, 135 as sine 180, all right, sine 180 minus, all right, now 180 minus, all right, sine 180 minus, all right, you can write it as 45. Sine 180 minus 45, thereby technically becomes sine 45. Do I know the value of sine 45? Yes, which is 1 by root 2. That is all I'm going to substitute it here. Let's substitute it here. So therefore you will say that this is nothing but half 15 and this is 12. Sine 135 is nothing but 1 divided by root 2. Why? Sine 135 is as good as sine 45. Sine 135 is as good as sine 45. This is the relationship that you will know, right? I want you to be little aware of the basic elements of trigonometry. I would rather suggest go back to your cheat sheet, go back to your formula sheet of class 10 trigonometry, or you can Google it and just try and remember whatever has come there, because in the further classes also I'll be using little bit of trigonometry, little bit of that I'm going to use it. If you run through those cheat sheet, that particular formula, trust me, you'll become far more efficient in doing some of the algebra, all right, some of the questions of geometry. You become far more efficient. Otherwise what it does is it will simply rob some time out of it, all right, it will simply rob some time. So ensure that okay, it doesn't rob much of our time, all right, thereby all right, you will be able to therefore all right, I want you to go back and look at the cheat sheet of class 10 trigonometry. It will be very easy to recall. It will not take some time, it will not take much time. Just there will be couple of things there. Just go forward and just remember those trigonometric identities, double angles, etc. Right, the double angles, etc. Of course, as you know, the answer has to be a here, without even bothering to trying to simplify, because already there is a root 2 here, therefore that cannot be cancelled, therefore the choice becomes a in this question. Fine, let's go further, friends. Let's go further. Let's learn one more concept here. Let's learn a concept quickly. I'll teach you a simple concept here. Take a look at this question first. Right, okay, D and E are the points on AB and BC respectively, such that AD and DB are in the ratio 2:3. Already AD and DB are in the ratio 2:3. Let me put it like this: if this is 2x, this has to be 3x. AD and DB are in the ratio 2:3, and BE and EC are in the ratio 4:5. Right, therefore if I write this as 4y, this has to be 5y. This has to be 5y. Find the ratio of the area of, or let's find the ratio of area of DBE. He's saying that DBE to the quadrilateral DEC. We already did this question, no problem. There is a common angle theta here. Think about it, isn't it? There is a common angle theta here. Therefore, one way, all right, now you find the angle DEB. Wait, I'm teaching you another approach here, right? The area of the triangle DEB. All right, if I'm writing the area of the triangle DEB, what is that you are trying to say? Half. All right, you are saying that 3x and 4y, and the sine of the angle between the two things, that is sine theta. We know this approach. I'm coming to another approach because I'm going to cat question after this. This is not a cat question. The question after this is a cat question. Therefore, I'm reaching there. To reach there, I'm making one point out here. Then triangle. All right, let's take a triangle. All right, ABC. All right, now let's take a triangle ABC, because a triangle can be compared with a triangle. Therefore, half. All right, now what is that corresponding side? 3x plus 2x, 5x. All right, then 4y and 5y, all right, which becomes 9y. All right, 9y into, what is the sine of the angle between them? Same sine theta. I can find this ratio here, right? I can find this particular ratio here. So everything gets cancelled. All right, now these fellows get cancelled here. Therefore, you are saying that, okay, this is nothing but 12 divided by 45. You can simplify it. You can simplify it 3-4 times, and then you can say 315 times. That's also fine. All right, that's also fine. 4 by 15 could be the answer, right? 4 by 15 could be the answer. Therefore, if you call this as 4 units, the total was 15 units. Therefore, this quadrilateral will be 15 minus 4 units, all right, which is nothing but 11 units. That's the required answer, right? Quadrilateral ADEC, all it would be that. But now listen, another way of dealing with this. Just listen to me, my friends. Just listen to me. If there is a common angle, all right, if there is a common angle, simply put, all right, now simply put, how do you write this particular side is? What I do for the bigger triangle, all right, bigger triangle ABC is, I will simply take the product of all possible sides given to me. What do you mean? 3 into 5, 3 into 2, 5 I will write. 4 into 5, 20. All right, 3 plus 2, 5. All right, then 4 plus 5. All right, now that's nothing but 9. I will take that outer triangle ABC is equivalent of 5 into 9, 45 square units. I will take it as 45. Now look at this. I want to find this particular piece. How do I write the area of this particular piece? Is, listen to me, guys. Listen to me. 4 out of 9, because 4 plus 5 is 9. 4 plus 5 is 9. I will write this as 4 out of 9 into, now look at this, this is 3 out of 3 plus 2, 5. Therefore 3 divided by 5 times of the bigger triangle, which is 45. So I will cancel this 45 with this. Now I'm trying to say that therefore the area of the smaller triangle inside, area of the smaller triangle inside is 4 into 3, 12. I got this 12 when I took the outer one as 45. Did I get the same thing, 12 on 45? Yes. All right, once I understand the common angle, this is another way. This is called as a ratio approach. This is called as the ratio approach. By identifying the outer triangle. Outer triangle, you assume the outer triangle and try to write the areas of the inner triangle. Okay, the point will become very clear when I do the next CAT question. Let's apply this in a mega scale. Let's go to CAT question. So here is a CAT question. Let's go to the CAT question. Let's use this on this particular CAT question. Same concept. Let's use it here. Just read this question once. All of you read this question once. We'll go to this CAT question. Using this question, my concept becomes very clear. What I'm trying to say would become clear to you. Apply it here. Apply it here. With this, it becomes clear. Just read it. Read it. Do it along with me. No worries. We'll do it together. All right, here we go. In triangle ABC, as shown in this particular figure, DEF are the points of trisection points. The trisection can be a wrong word. Points, solid points on BC, AC, and AB. That's it. No trisection there. All right, no, that's a mistake. Okay, so AB, this. All right, now how many times is the area of DEF? All right, the hashed one. All right, this one, DEF. All right, in comparison with EDC. In comparison with EDC, where is EDC? Here. So he's saying that why don't you compare these two fellows? Very good. Now take a look at this. Listen to me carefully. AF and FB are in the ratio 1:2. Let me write 1 here. Let me write 2 here. If you want to write 1x, you can write 2x. There is absolutely no problem. But 1 and 2 are good enough for me. 1 and 2 are good enough for me. Okay. Then BD and DC. If I write this as 1y, I know that, okay, I can write this as 3y. But y is not required. But anyway, for your comfort, I'm writing it. Okay. CE and EA are in the ratio. If I write it as 2z, then I should be writing this as 3z. Okay, now what matters to me? First, make an assumption for the outer triangle ABC. What can be the let's make an assumption for the area of outer triangle ABC. How do you make the outer triangle ABC? Consider these two sides. 3 plus 2, 5. 1 plus 3, 4. 3 plus 2, 5. This 3 plus 2, 5. Hey, what about XYZ? Leave it. That XYZ I only wrote for your comfort. You are comfortable, then I will remove it. If you are comfortable, I will remove it. All that does not matter to me. What matters to me is only numbers. Numbers. I will tell you the ratio after that. Because anyway, you have to tell me how many times is something when compared with something. Nothing but a ratio. So why do I need XYZ? That will anyway get cancelled there. Okay. Now, all right. Now, so I got those numbers. 5. All right. Now, 3. All right, 3 here. This was 3. 1 plus 2, 3. 3, 4, and 5. All right, we got those particular numbers. Now listen to me, guys. Listen to me. That's outer triangle. I'll take the outer triangle as 3 into 4 into 5. That's it. I will take the area of the outer triangle as 5 4 times 20 into 3, which is nothing but 60. I will take this as 60 as the outer one. Okay, all of you got, I guess. So far, I'm assuming that you are all with me. What did I do? I added this 1 and 2, called it as 3. I added this 1 and 3, called it as 4. I added this 3 and 2, called it as 5. All right, now, so therefore, what did I do here after that? After that, I just took those numbers, I multiplied. I said that let that be the assumed area. That's not the area because everything is given in the terms of ratio. Nobody on earth can find the area of this triangle because everything is ratio there. So it's an assumed area based on the numbers given to me. Based on the numbers given to me, that's my area. Fair enough. Okay. So therefore, what will be the area of this piece now? All right, what will be the area of this piece? I want to find the area of this piece. Simple, friends. Area of this piece is nothing but now look at this. 2 out of 3. 2 out of 3 into, look at this, 1 out of 4. 1 out of 4. 1 out of 4 into 60. Into 60. Out of 60, how much? All right, this is 2 out of 3 total. This is 1 out of 4, that's a total. Therefore, out of 60, it's going to be how much? Out of 60, it's going to be how much? It's going to be 10. All right, it's out of 60, it's going to be 10. Out of 60, it's going to be 10 units. Good. Okay, which means if the total is 60, you are saying that the area of this smaller piece here, area of this piece is nothing but 10 units. Fantastic. All right. So let me find the area of this piece now. Let me find the area of this piece, my friends. Let me find the area of this piece here. Let me find this. All right, let me find this particular piece. How do I write? 3 out of 5. You'll write this as 3 out of 5. So how do you write this? 1 out of 3. All right, these are the methods what I'm teaching here. 1 out of 3. All right, this one. All right, now governing like write that 1 out of 3. All right, into what? Into 60, because that out of 60 total how much? 3 out of 5 and 1 out of 3. Therefore, out of 60, it's going to be how much? All right, therefore, you will say that that's going to be 12 units. Very good. This is going to be 12 units. All right, therefore, that hashed portion is that portion is becoming 12 units there. Fair enough. Similarly, write it here, my friends. Write it here. All right, let's write it here as well. Let's write it here. Let's write it here. What you are writing? 2 out of 5. You are saying that, okay, this is 2 out of 5. All right, now this side 3 out of 4. This side it is 3 out of 4. Out of 60, how much? Therefore, out of 60, it's going to be how much? Right? Yeah. So out of 60, how much here? Therefore, you will say that, okay, this is another 12 units. This is going to be another 12 units. All right, this is another 12 units. Sorry, 18 units. 18 units. This is going to be 18 units here. All right, this is 8 units. Good. So simplify this. All right, simplify this. This is getting me 8 units. All right, this is getting me 8 units. Good. So far you are with me. All right, now therefore, hey, what is this middle piece, by the way? This middle piece, by the way, this middle piece is nothing but 60 minus this piece 12, subtract. All right, this piece 10, subtract. This piece 18, subtract these pieces. That becomes the area of this particular piece, isn't it? 60 minus all these particular pieces. All right, that's nothing but 40. Therefore, this becomes 20 here. All right, therefore, this becomes 20 here. Now, what is that author is trying to say? DEF in comparison with EDC. Yeah, what is DEF? DEF is nothing but 20, because that's how you reach the inside area. 20 divided by, in comparison with this 18. 20 divided by 18, that is the multiplication factor. How many times? This itself is those many times. All right, that's nothing but 10 divided by 9. All right, that's those many times. All right, the area of triangle DEF is 10 by 9 times of the area of the triangle EDC. Simple. I hope, all right, with this example, everybody's clear with what I'm talking. All right, with this example, I believe that everybody's clear what I'm talking here. Very good. Wow, very good. All right, with this example, it should be clear. What is this method? This is the method of assuming the areas. All right, one of the important concepts in CAT. How do you assume the area? From there, how do you approach the area of each piece? All right, each piece that has been created inside that particular triangle. How do you approach that? All right, that's a point I was trying to make. All right, that's a point I was trying to make. All right, let's go to the next one. Let's go to the next one. Another beautiful question. Let's take a look at this question, friends. Let's take a look at this question. Another 10 minutes, we are done. Another 10 minutes, we are done. Couple more questions. Let's go through a couple more questions and we are done, guys. Let's take a look at this question. Take a look at this question. Read through. We'll do it together. Read through. Last 10 minutes, do it with me. Right? Okay. What is given to me? AB is 5. Let me mark those sides. This is given to me as 5. AC is 12. This is given to me as 12. AD is equal to 4. All right. And AD is perpendicular as well. That's 4. Okay. That's given to me as 4. That's given to me as 4 as well. Find the length of circumradius of the circle that can be drawn for the triangle ABC. He's saying that, look man, all right, for this triangle ABC, put as a radius circle. So what is the circumradius of this particular circle? This side is easy. You will find this as 3. But this side is tedious. This you will write it as 12 square minus 4 square becomes such a tedious one. So may not be required. Now listen to me very carefully, friends. Listen to me very, very carefully, my dear friends. So let me call the third side as X. Let me call the third side as, let me call the third side. Okay, let me call the third side as C. Let me call the third side as C. Let me call this side is equal to A and this side is equal to B and this side is equal to C. Yeah, how do you find the area? I told you, I deliberately wanted to do an example on this. Area of a triangle can be written as ABC divided by 4R, isn't it? ABC divided by 4R. That's one way to write the area of the triangle. Area of the triangle can also be written as half base into height. Hey, what is the base here? I will take C as the base. I will take C as the base. Hey, what is the height here? I will take 4 as the height. I will take 4 as the height. I will take 4 as the height. Now, what is C? I don't have to know. Why I should know what is C? C and C is anyway getting cancelled. There is C there, but is it any importance there? I don't see any importance attached with that. Do I know the values of A and B? Yes, value of A is 5. Value of B is 12. Value of B is 12. 4 times of circumradius is equal to half into 4. Did you get the value of circumradius from here? Yes, because C has no importance there. See, my point here is what? As long as you are able to recall that area can be written as ABC divided by 4R, your life has been sorted. Your life has been done. So therefore, from here you can calculate further. This is 4 3 times. All right, this is nothing but 2 2 times. All right, 2 times. Therefore, you will say that circumradius. Therefore, circumradius is nothing but 15 divided by 2, that is 7.5. All right, that is the required response here. What is the circumradius of this particular triangle? Because that's a question here. What is the circumradius? You are saying that it is nothing but 7.5 units. 7.5 units. Simple one. Simple one. You just have to understand that, okay, what was the only important thing here? Do I know all 5 formulas of the area? Is my trigger working properly? Once I understand that the circumradius, I'm able to recall sufficiently about that and try to apply the concept with respect to it, right? With respect to it. Now look at this. This is a beautiful classic CAT question. It's a beautiful and a classic CAS question. It's a very beautiful question and a classic CAT question. Probably we can stop with this. All right, with this, most of my inputs will get done with respect to triangles. Let's take a look at this question. Beautiful one. And the classic one, must know. This must be known to all. Yeah, so what is the problem with this? Is a CAT question. Well, this is a CAT question only, as it is right now. So this is a CAT question. What is the problem with this? A lot of people forget the construction line. That's it. All right, in this question, people all right now will not consider the construction line. If you don't consider the construction line, then you will be badly stuck. So what is the construction line? I told you in the last class, construction line, all right, the line has to pass through one of the given points. All right, one point and parallel to another line, or connect 2 points. These are the two ways to do the construction line. Because in the last class itself, while doing the first 2 or 3 examples, I told you about this. In the angles itself, I made it clear constructions are important. Now look at this. I will draw a construction here. See, you might not understand that which is the right construction here. That's all right. That's all right. Which is the right construction, you might not know. Sometimes you may think that, okay, is this the right construction, passing from the point E and parallel to this? All right, that's a point there. Okay, that's all right. Draw 1 or 2 lines here and there. Things will become clear. And once you become a pro, once you become a veteran, you will understand that, okay, I know which construction to be done. It's easier. You have to find out AE is to EC. Therefore, construction, let it go on this side, because you're ultimately finding AE is to EC. You're going that side. If you're going that side, why not do a construction towards that particular line? Fine, guys. All right, now this is where the construction is going. Now look at this AM. All right, now look at this. BD and DC are in the ratio 3:4. This is in the ratio 3:4. If this is in the ratio 3:4, then I will say that this is also in the ratio 3:4. All right, this is also in the ratio 3:4. Oh, suddenly how do you understand that that's in the ratio 3:4? All right, because of the basic proportionality theorem. Because of the basic proportionality theorem. If this is in the ratio 3:4, then this also will be in the ratio 3:4. All right, similar way. All right, that also gets split in the similar proportion there. All right, BD is to DC will also be in the similar proportion of 3:4 there. All right, that also would be in the ratio 3:4. I hope all of you got this particular point, what I'm trying to say. Right, all of you got this particular point. What is that? I simply applied the basic proportionality theorem on this triangle. On this triangle, my friends, I just applied the basic proportionality theorem on the triangle. All right, on the triangle. All right, on the triangle BEC. On the triangle BEC, I applied a basic proportionality theorem. If this ratio is 3:4, this ratio will be also be 3:4. The lengths can be different. See, I'm not claiming that the length will be same. If this is 3x, this can be 3y. If this is 4x, and this can be 4y. I agree with that. That can be different, but the ratio will remain same. That's my point. Ratio will remain same. Very good. All right, this ratio will remain same. Next one. Now listen to me. Go to the next point here. AM and MD are in the ratio 2:1. Here he's saying that AM and MD are in the ratio 2:1. This is 2 and this is 1. Again, apply the basic proportionality theorem on which triangle, friends? On the triangle. All right, now let me call this point as N. Let me call this point as N. Look at the triangle ADN. All right, N is the point I have inserted here. N is the point I have inserted here. Look at the triangle ADN. In the triangle ADN, apply the basic proportionality theorem. Then this ratio will also be 2:1. Now look, 1 corresponds to 3. Therefore, 2 corresponds to how much? 6. Therefore, 2 corresponds to how much? 6. Okay, because I already said this is 2:1. Therefore, this ratio will also be 2:1, but already 3 is there for me. If 3 is there, make all it 1 corresponds to 3. Therefore, 2 should corresponds to how much? 6. Now write that required ratio. Therefore, what is AE, my friend? AE corresponds to 6. What is EC, my friend? EC corresponds to 3 plus 4. All right, EC corresponds to 3 plus 4. That's a required answer, 6/7. Such a beautiful CAT question. What was the parameters involved here? Simple parameter involved here in this particular question was doing a construction. That was very, very important. All right, one of the important thing was doing a construction. The second important thing out here was drawing, all it now, so understanding the applying the basic proportionality theorem twice. Well, it applied twice and we are sorted. We are done with this. 6 by 7 was the required answer in this particular question. I hope everybody enjoyed this particular lecture. I'm going to close it here. So I gave as many inputs as possible with respect to triangles, as many as possible. Okay, but there is never an end to it. If I have to talk about triangles, I can keep on talking about it. But somewhere I got to give a closure on it, and then you will pull out from there. Where I stop, that's where you begin. That's where you begin. You can revise some of these particular questions and then look at the new exposure to this particular question, different exposure, and try and work on these particular concept. But did I cover the entire breadth of the basics? Yes. Well, the entire breadth of the basic is clear covered. So you just have to build on this particular basics. Once I finish my quadrilaterals and circles, you'll be able to connect much more better with respect to geometry. Wait till now we complete our quadrilaterals, the polygons, and then the circles, especially the circles. Circles and triangles is a beautiful combination. Once you complete your circles and the triangles, you are sorted. Your life is completely sorted. All right, that's about today's lecture. I will see you in my next lecture. Let's stay fit, start working on the let's keep working. I will see you. Bye till then. Stay blessed.